Hello everyone, welcome to Matlab Programming course. My name is Hossein Tutunchi and I'm a teacher assistant at California State University, Fullerton. In this video course, I'm going to show you how you can use Matlab programming to gain better results either in your school work or in your profession. Therefore, if you are a student in electrical engineering, mechanical engineering, or any other STEM-based major, or on the other hand, you are a professional working in industry and you want to just hone your skills and advance in your career, then you will find this course really helpful. There is something amazing about Matlab programming, and it is that almost for any major out there, there is a toolbox installed in this amazing software. And for example, you can verify the toolboxes and start working with the one toolbox that you're interested. For instance, if you're a musician or a biologist or you're active in data analysis, economics, as you see, there are thousands of pre-written functions inside Matlab that we can learn and start working with and instantly get the better results. What Matlab does at the root is doing sophisticated mathematical functions and formulations for you, and it is the most widely engineering tool used for the design, analysis, and data crunching. In this course, I'm using Matlab 2013, but you can use previous versions. However, I strongly suggest that you install version 2009 above. And in terms of Windows or Macintosh, there is absolutely no difference whatsoever in terms of results or the final output. They're almost identical. I'm really excited to start this wonderful course with you, and let's get started. In this part, I would like to introduce you to different parts of Matlab, and we're going to use them very much on a daily basis as we progress through the course. I begin by the biggest part in the middle, which this part is called the command window. It's the place that we tell Matlab what we're gonna do and then get the results. So it's where we communicate with the program and we introduce our inputs to the Matlab, and then on the other hand, the Matlab will do the calculations and reflects back the result in terms of a number or a graph most of the time. For instance, if I type 1 plus 1 and hit enter, you see that the result is reflected back. And at the same time, you will notice that in the workspace that I will going to talk about in a minute, another activity is just taking place. Something with the name of ANS is created and its value is now 2. Back to command window, let's do another calculation. If I say 3 plus 4, and hit enter, you'll notice that the result is now 7, and here the ANS is 7 as well. What's going on here is the fact that ANS stands for answer. Therefore, answer is the default variable in Matlab which holds the last calculation result. Therefore, if I do another calculation here, always the result is going to be stored in a variable here called ANS. To verify that, let's do 34 multiplied by 891. Hit enter, and as you see, the result will be updated to the last calculation. On the right hand side, the workspace is a place that holds the list of variables. I just explained the answer, but I would like to show you that if I introduce another variable here like a equals 2, and don't worry if you don't know how to introduce variables into Matlab, there is a separate chapter and video about it, and I'm going to explain that in future videos. In this part, I'm going to clear the part by a very simple example. Therefore, if I type a equals 2, which means put the value of a equals to 2 and hit enter, you will notice that the answer is not changed, but a new variable is created. The reason is that here we're no longer dependent on the answer, but we also introduce a new variable called a. If I introduce another one with the b, then you see that another variable is also created. Therefore, the workspace is a place where we can see the list of the variables we have introduced. As we progress through the course and we learn how to program with Matlab, there are gonna be programs we write that contain contain more than 10 or even more variables here, and it is very useful that we can see the list of variables at a glance. Below the workspace is a command history. This is also a very useful part. Command history basically is a place where the Matlab keeps a record of our activities. And as you notice, it is time stamped. Therefore, whatever activity that I'm going to perform today is going to be recorded. As you notice, these are the activities that I just performed. If you come back here tomorrow, another time and date stamp will be created and is going to record everything we're going to do. It is very handy because sometimes you want to do a calculation again and you need to find it very fast, especially if it is among the last ones you perform. And it is very handy because if I'm interested to do this multiplication again, if I find it, the only thing I need to do is to double click on it and it will be calculated again. On the left hand side, there is a current folder. The current folder is a private and dedicated folder for Matlab that records all the calculations and programs that we saved there. And I'm going to explain how we're going to save our programs in a future video. If you notice, there is a toolbar up there that if I click on it, it will give me some path I can select. And basically what it does is giving Matlab the selection of the option to choose the output folder and where we can do the calculations. So basically what it does is it will give us the ability to choose the path Matlab is going to work. And I suggest you that you keep it as the default, which for me it is in document folder in Matlab. Above that, you will notice that we do have a standard toolbar along with some new ones which are specifically designed for Matlab. I will going to brief you about each one of these throughout the course. Of course, there are some of those that we don't use, but I will make sure that I will explain the most important ones. If you look closely, you will see that there are 3 tabs up here. The first one is Home, the second one is Plots, and the third one is Apps. The Plots is a handy bar that will give us the option to choose which form of output we're interested. For example, in one specific example, when you calculated the result, you might like to have the histogram of the output as well. So just by one click, you can find it. Or sometimes you're interested in finding the pie diagram of a problem. Absolutely no difference. But most of the time, we're going to use the plot, which is the simple form of graph we use. The apps part is very interesting. You can look at them pretty much as the apps you install on your smartphone or tablet. So there are pre-written apps, which most of them are for general purpose. But if you come here and click there, you will find that there are a lot of special apps written for any specific major. For example, the biology, there are many items available, and there are very interesting ones here as well. As an instance, there is a code generation app that what it does is when we write a workable code in Matlab, then it enables you to translate that code into C or C++ language seamlessly. And it is actually the process that is used in many engineering firms because Matlab has a lot of functions, has a lot of pre-built functions. What engineers normally do is to use the amazing capabilities of the software to come up with the desired results and then optimize it. And finally, they will translate this into Matlab code. Then translate the code into C or C++. There are, of course, many curve fitting and optimization tools available. Hello everyone, welcome back to Matlab Programming course. Today we're going to cover one of the most important concepts in Matlab Programming, and it is saving our results to start working with them later on. If you come to left side of your Matlab interface, the current folder, you'll notice that yours probably is empty because you just installed it and you haven't saved any project or work inside that. However, when you do, you're given the ability to create folders and also new file, which is going to be functions, scripts, and stuff like that. For instance, I do have a test script here. I've created a test script, and now I'm going to create another one by clicking on the new script and calling test2. I can save it, and then Matlab asks, where do you want to save it? And I point out to the default location where Matlab installs all the files. So I call this test2, and if I hit enter, you will notice that the new file is just created here. You might be tempted to do this. For example, I do 2 multiplied 7. I'm just creating random numbers and calculations. So 83 minus 2, x equals 4, and stuff like this. And you see that in Workspace also there are new variables created, the command history as well. However, you might be tempted to do this. Save Workspace, and let me save it here. Save Workspace. Hit enter, and you will notice that, okay, the new save Workspace is created, and okay, so I'm fine. When you clear the screen and let's say tomorrow you come back to resume your work, you will notice that by clicking on this, only the workspace and the values saved inside the variables are here, but no calculation, no formula, no nothing is created. Therefore, it is very important to realize the difference between creating a script and also save workspace. Fortunately, Matlab saves all the records in command history for us. Therefore, if you need to do the calculation, you see the result, you can come here and review it and just get everything here you've done before. However, things are not that easy all the time. There are programs and algorithms that may be 1,000 lines, and it's not feasible for people to just go over review it line by line. To avoid such problems, we create scripts like this. So in scripts, you are able to save anything you want. So let me call it x3, y equals 5, and then when I save it and close it, if I come here tomorrow and type test2, you will see that the new variables are created here for me. So these are the new variables, and also I can resume my work by clicking on it. It's always there. Another additional benefit is that I'm able to email this to anybody I like. So this is a transferable, and everybody with the Matlab install can open the file and start working with this. Therefore, please make sure that you completely understand the difference between the script and the saving workspace. It is one of the major sources of frustration for beginners. With that said, I will see you in next video. Hello and welcome back. In this video, I'm going to introduce you two functions that literally without them, you're not able to learn Matlab. So what are those functions that are very, very important? The first one is help. And why the help is so important? Because I literally never read the help of other softwares, but I picked them up. However, I can't do the same with Matlab. Well, the help of Matlab is a little bit different. Let me show it to you. First of all, you can access the help in different forms. For instance, if you come up and on your menu bar in Mac, the upper part, there is a help. If you click on it, you can search for whatever you're after. But first, let me show here. For instance, you want to find CLC, right? CLC, this function would clear everything. But for example, you want to know more about it. The way to do it is to type help CLC. As you see, if you type it, inside the Matlab, it will gonna bring a short description about it, and it will going to explain more about that function. Another one is the ABS, which stands for absolute value of a function or variable. And so if I type help ABS and hit enter, as you see, it will bring another and more description about this function, and I can even see other suggested items here. Throughout the course, there are some more complex functions that they do have arguments in predefined format, and you need to know how to insert them. It's a very good habit to double check everything before typing it in Matlab. So the other one that is really important, let me first CLC, which clears everything. So the other one is DOC, which stands for documentation, right? If I say DOC, say ABS, right? If I hit enter, the documentation will pop up, and it is really, really amazing. But be careful, this is a very detailed and huge set of information, and do not treat it as like a tutorial or a learning manual, because you're not going to finish it in any way. This is huge. The best way to learn it is through context. If you're working on apps, just search the apps function and see how you can use it and what are the other additional functionalities that you possibly can benefit. Let me read from start to the finish thing because it's really, really big. Another one, let's do DOC clear. DOC clear. So it will give us more information about the clear function that I'm going to explain right now, and therefore this documentation works for everything. Alright, so let's do CLC. If you pay attention in the workspace, we have done a lot of calculations and many results are created, like 4 results and values are stored in variables. You might like to clear them, right? Because we don't need the x -9 for everything. If I type here x at the moment and hit enter, the -9 is going to be reflected back because the value is stored in it. But the -9 is not going to be the case for every single program I will write. Therefore, it's a good habit to clear your workspace if you're going to work on multiple programs. The way to do it is through a function called clear. So I type clear space and then I type the name of the variable I want to get rid of. For instance, here I would like to say x. Clear x. And you notice that the color of the variables is also indicated. It's different, indicating that it is variable, not a simple typing. So if I hit enter, you will notice that A is deleted. And if, as a matter of fact, if I type X here, you will notice that no value is assigned to it. It's just empty. Let's do it for other variables. Another way to clear everything in Matlab, because chances are you have created a lot of variables and just clear X, clear Y, clear Z is not going to be a very efficient way of doing so. Therefore, another function is called clear all. And you can guess what it does. It will clear everything. So I would like you to look at this window, the workspace, as I hit enter in the main window. Boom, everything is cleared. How about the command history? The command history, you can come here and click on this icon and clear command history very simply. It will ask you, do you want to really clear everything? Yes. Back to the main menu, you can say CLC and we're ready to start our programming. Believe me or not, you have learned some of the most frequently Matlab functions so far, and we're ready to explore more in future videos. So let's get started. Hello guys, in this part I'm going to show you 2 of the most important Matlab functions that we're going to use every day. So let's generate some calculations. I'm just going to do some random ones. And then x equals. You can use different values. Alright, I have done some calculations here, and sometimes you will need more space, right? Because after doing these calculations and even more, it's going to be jammed with information. It's not very easy to read things. One of the functions that I'm going to introduce to you is called home. The home function, if you hit enter, you will see that it will provide you with some additional information while preserving the previous calculations here. Therefore, whenever you need empty space to do more calculations while you need to keep the previous calculations also, the best way to do it is through home function. The home function will bring some new space. Another thing that actually we use a lot is CLC. What does CLC do is that unlike the home that keeps the previous information and calculation for you, it's going to wipe everything out. So if I type CLC and hit enter, you will notice that there's nothing left in command window. But if that happens to you, don't freak out because you do have the command history and all the calculations. You can go through it and hit enter, so the calculation is done and performed for you. One more thing that I would like to show you today is that, as you remember, the today test script that we created, and it contained 2 calculations we did. If you decided to work on it later, the only thing you need to do is to double click on it, and it will bring the window, the editor window, and you can add things to it as well. So y equals 6, then calculate x multiplied by y, and also y minus x. You save it again and run. If you come back here, you'll see that the today's test is run and everything is here. I would like to show you another way to do it as well. So let's do CLC, which clears everything. If you want to run a program that you saved here, you can simply type its name. So if I say today, underline, test, and pay attention to capital letters because they do make difference. So if you type it, the name, and hit enter, you will see that it's automatically run. It's a very, very handy way to do it. And I want to make sure that you learn the shortcuts as well. Hope you enjoyed this session, and I will see you next video. Hi everyone, I hope you've been enjoying the course so far, and today we're going to learn some new stuff. If you look at the command history at the right, you notice that a new timestamp and data stamp is recorded. I do have the previous calculations, as I told you before, and if I need them, they're like accessible for me and I can do whatever I need. Like double click on this and it's going to be repeated seamlessly. In this video, I want to start with the very basic thing because, as we promised, we're going to start from the basic and the fundamental things and then go up to advanced level. I would like to start with basic arithmetic. Let's define some variables. X equals to 12 and A equals to 2, B equals to 5. That's good. In order to do the multiplication, as most of you know, we use asterisk. So it is Shift 8 on your keyboard. A multiplied by B. And the result is 10. Next, I can do A and division, right? A division by B. And if I hit enter, it's going to calculate that. There is something interesting that, well, few people know, and it is that Matlab is able to do the backslash as a division as well. So if I say A backslash B, it's gonna go with the division. But what's the difference? You will notice that the value for B equals 5 and the value for A equals 2. So if I say A divided by B, it will be 0.4. If I say A backslash B and then hit enter, the result will be different. So you will notice that here B is divided by A, although A comes first. And also we do have summation and subtraction. Is the fact that there is an operation called the assignment, but there's a special way to write it. So if I say x equals 7, this is the result. How about this? Well, how come x plus 3 on the right side be equal to x? How can it be possible? Well, as you see, there is no error involved. And basically, it's a convention and a very normal way of adding value to a variable. So how we can read and interpret this? Basically, whatever the value of x is defined here, which is 7, is going to be stored in this part, x plus 3. So the value for x is 7, and then it is plus 3, which means 10. Then the whole value for in the right side will be substituted as the value of x. So if I say x equals x plus 1, the value for x, the last value is 10. Now we're going to add 1 to it, and the new value for x will be 11, as you see. How about x equals x minus 23? So the last value for x was 11, And now when we put 11 and subtract 23 units out of it, the result will be negative 12. And the new value for x will be negative 12 as well. One more thing. Is it correct to say x plus y? We do have the value for x, which is negative 12, and the value for y, which is 766. And then we defined a new variable called t. And if you hit enter, you will notice that it is done without an error. So it's definitely possible that we put the value of two variables and define a new variable for it as well. We could also find the value of this expression, and we call it the caret, x caret y, which is x to power y, and it's going to be infinite, of course. So let's go with y caret, and you see that the result is calculated. And I'm going to talk about the different forms of the result. But what I'd like you to do in this part is to calculate some basic arithmetic and practice on this, because we are going to use them a lot throughout the course. I am Hossein Tutunchi, and thank you for watching this video. See you in next one. Let's learn more about the variables in this part. Of course, I'm going to cover the variables in a separate video. However, there is something I would like to talk about it in this part because I believe it's going to help us along the way. So let's start fresh. As I explained earlier, if you wanted to assign a new variable, let's say x equals to 3, and then you need another one, if you prefer that the results will not be reflected back to Matlab, we learned that we can suppress the output in this way. We definitely are able to define new variables on the same line. So let's say x multiplied by y, and another one, let's go with d equals x minus y. So we define some variables, new ones, and because I forgot to put the last semicolon, the last one was reflected. But actually, if I wanted to do the last calculation, and I don't like, because I forgot to put the semicolon for the last one, the result came out, and I just didn't like it. So if I wanted to calculate everything and start fresh, is to do CLC and just clear everything, and then come here, double click on it, and put semicolon, right? For example, if I say CLC, let me show you, and then I come here, double click on it, it's going to be executed, but I didn't want that operation to show me the result. But actually there is no way I can do that, because if I bring everything here, it's going to be calculated. Well, one way to do it is to click on this operation and then drag drop it here without pressing enter. Now you have the option to go around and just do the revising, whatever you need to do, and then add things on it to correct ourselves. Another easy way that I suggest you from now on, just get habit of using that, is using your arrow keys. If I want to calculate the previous operation, the only thing I need to do is to press the up arrow key on your keyboard. So if I do that, the last one comes in. If I do it one more time, one operation before that comes in. So if I keep repeating that, the operations as the order I had performed them will appear here. Definitely I can do it backwards. So if I need that, I can easily calculate that. Or let's go with, I want to clear everything. Let's do this one again. I'm just pressing my up arrow key. This is really an easy and interesting way to find the last calculations we've done and reuse them again. The other thing that I already talked about was the operation who will give us the list of the variables that we used already in our homework or project. Therefore, we're not able to use these things. I'm definitely able to say a equals 2 and the value will be changed, or a equals to 76, the value will be changed. However, I should be careful not to override my previous calculations, especially when you write a program. In a program, the variables are defined once and the variable name is not shared with others. Therefore, we should be careful not to override our variables. Another operation that is useful is whose. So add another S to the last operation, who, and if you hit enter, now it will give you more information. So A size is 1 by 1, which is a number, a scalar, and I'm going to explain about the vector and matrices in future videos. The bytes is 8, class is double, and I'm going to explain all this stuff. You can get more information about your used variable by who, which gives you a list, and whose, which gives you more information and other stuff about the size and the class and even more information. Thank you, and I will see you next video. In this part, I would like to talk about the order of operations, which plays a crucial role in our calculations. So if I say 1 plus 2 plus 3, and the result will be 6, 1 plus 2 multiplied by 3, then the result will be 7, because this calculation is going to be done first. So 2 multiplied by 3 will be 6, and then 1 added. However, if I say, and I'm using the up arrow key to bring the last operation, and then I'm going to put this part into parentheses. Now the result will be 9. So Matlab is completely aware of the order of operations, and you will need to constantly be aware of that fact, and it is one of the sources of error that especially beginners in Matlab programming will get different results from those that they had expected. So if I wanted to show it in a more complex way, I can, let's say 1 plus 345, I'm just making some numbers, and then the whole thing then divided by minus, then multiplied by 43. Okay, so what's going on here is the fact that first, the first thing that's going to happen is this part will be calculated, then will be added to 1, and this is going to be the numerator, and then in the denominator, this part will be multiplied together, then will be subtracted from this value, and the whole thing is going to make the denominator. Then the division will take place. So the order plays a very important role. Let me clear up this screen to give you another example. So what if we want to say -1 to power 2, right? So it's going to be 1. But if you pay attention, you will notice that it's not 1, but it's -1. And the reason is exactly the order of operation. So what we did here, we excluded the negative sign out of this square operation. So if you want to calculate that, you will need to include -1 inside parentheses. Then the whole thing is going to be squared. As I told you, because we think intuitively that, okay, -1 squared is going to be 1, but that's not the way it's not the way the Matlab evaluates things. Therefore, in many cases, that's a source of error. I strongly suggest that you practice examples like this and create some example of yours, or surf the internet and find the calculations as an example. And this way you feel comfortable working with Matlab along the way. Hi everyone, welcome back to Matlab Fundamental course. In this part, I would like to talk about format, and I will expand that into future videos later, but this is actually essential for the rest of the course. So if I need to calculate 12 multiplied by 87, Matlab has no problem to calculate the result. And how about we go like 6.5 multiplied by 10 to power 3. How about that? So if I calculate this, Matlab will give us the result. Now I'm using the upper arrow key to bring the last operation, and then I'm going to change this. Let's go to 2. And I change the operation and put the negative sign in front of it. And if I calculate the result, you will notice that there's no problem with that too. So let me calculate the 3. No problem. But what happens if I calculate such a thing, power 43? So if I calculate such a thing, the result here is 1.46 and then a series of number, and then E, which stands for exponent, plus 10. So what it means, let's calculate it. If I say 2.4 e plus 3 and hit enter, you will notice that the result is 2400. So we can conclude that e plus 3 stands for 10 to power 3. It's another form of writing this. If I say 2.4 multiplied by 10 to power 3, you'll notice the result is the same. I can write it both ways. But how about if I change this 2.4e, then negative 3? It will work the same way, but now it is divided by 10 to power 3. I can easily say 2.4 multiplied by 10 to power negative 3. And you will see that the result is the same. So from now on, to ease our calculations, instead of using 10 squared or 10 cubed, we can use exponent. The last part that I would like to talk in this video is introduction of the pi constant. The pi constant. This is one of the most widely used parameters and constant we're gonna use that we will encounter in engineering field. The pi is introduced as pi. If I hit enter, the value is created. And as you know, this is not the long format. This is the short format that is sufficient for most of the engineering calculations, and we're going to stick to that throughout the course. And please notice that if you type capital PI, well, it doesn't know it, and will suggest to you that did you mean this one? And you will say yes. One of the reasons that I told you to upgrade to the latest version of Matlab was this feature or the suggestion. In older versions, you either have to do it right or you have to go search for it. However, in newer versions, it will search it for you and just give you suggestion maybe and give you a smart suggestion so you can continue your work. And as all the other constants, you can use it as a cube. You can calculate that. Definitely then you can say 2 pi minus pi plus pi divided by 2 squared, and Matlab has no problem calculating that for you. Or even you can say 34 to power pi. So then you can do whatever you want with pi as a constant, and we will work and practice on future examples which contains pi. They would get rid of all the variables that I particularly assigned for that I can find. These are the list of variables. The first thing that I do, as we learn, is to say clear all. And if I do that, all the variables is clear. I would suggest that we start by the program that we wrote here the other day. So if I double click on that, the script will appear. So let's get rid of everything. One more thing that I would like to show you before we start is the percent sign. You'll notice that the percent is written in green. So what it does, if I say 1 plus 1 and then run it, the result will be appeared here, right? However, if I get rid of this and then I put a percent sign in front of that, the whole thing turns green, and if I calculate it, you will notice that no result will come up. And why is that? You've learned a very, very important and useful tool. In Matlab, once you type percent in front of a command, the whole line will not be executed, or it will be treated as a comment. So I would be able to write here, I wanted to add 2 numbers in this script. And it is really useful because you are able to write notes in middle of your programs. So tomorrow when you come back to that, you can read this and remember the last part you've done. And this feature will make the programmer lives much easier, especially once you get hang of Matlab and you start writing a lot of programs. Then after a while, 1 month or let's say 6 months, 1 year, when you get back to the old programs, believe me, you will not remember anything. What was this part for? And it is really important that you explain yourself through notes And it is an essential part of Matlab programming once you send your program to someone else. The lines hopefully make sense to you, but another person who reads the program for the first time, it might not be as easy as you think. Back to our example, I would like to say in this example, I want to calculate the number of people who are coming to my birthday party. Okay, so I would like to throw a birthday party, and I need to know how many people are coming, right? Because I want to prepare the house and the stuff and the food. So let's write the program. First of all, what I need to do is the number of the people that is coming to my party is the number of my friends plus the number of my sister's friends plus the number of the people my mother invites and the number of the people my father invites. I know it's kind of boring birthday. Just we wanted to write the program. That's it. So let's start with that. The number of people I invite is 23. For my sister, say 4. And parents equals 6, which will be different. Of course, I didn't pick up the right names like me and sister and parents. Doesn't make sense. The value of me is 23. But because I know I'm writing this, it's fine. So I would like to say total people equals me plus sister plus parents. And this is the result. So if I now come and run the program and you come back here, you will see that the total people is 33. The total people who are coming to my party is 33. Let's write another one. In this part, I'm going to be more technical. In this example, I am writing a program to calculate the volume of a sphere. And as you know, the volume of a sphere is calculated as, if V stands for volume, it's 4 divided by 3 multiplied by pi multiplied by radius cube, right? This is the volume of a sphere. So what are the variables? Volume equals V. The next one, I'm just preparing a legend. And the pi, we know it. The R is radius. The R is radius. So this is the legend. I've made a mistake here. Okay. I would like to write the exact thing. So volume or V equals 4 divided by 3 multiplied pi multiplied R cubed. This is the formula. But in order to calculate it, we do have the pi. We don't have the value of R. So before that, we define the value of R. R equals 5. Then the volume will be calculated as this. Let's run that. The value for volume is calculated. And as you see, the previous calculation and results is also here. Therefore, a very, very practical norm that you need to apply in all of your programs and scripts is that before you start everything, always include these two commands. Clear all, CLC. Clear all and CLC. Let's start from the beginning. These two will be read, but because they are comments, they're ignored. Then these two will be read. Again, they're ignored because they're comments. Then we come to here, and then clear all will erase everything. CLC will clear everything on a screen, including the clear command that we have just typed. Then R will be performed, and then V will be performed. So let's do that. If I run this, you'll notice that we do have a clear calculation. Even we can, instead of this, we use volume. Volume is this. So I calculate it, and you will see that the result is now volume. Please try to just create some calculations for yourself, because once you work with it, it will help you a lot. Hello guys, in this part we would like to explore further capabilities in Matlab, and one of the most important ones that we're going to learn is the symbolic calculations. And I cannot emphasize it more that how important this feature in Matlab is, and it is one of the reasons that Matlab is so popular. And it is the ability to calculate symbolically. It's interesting to know that Matlab inherently does not calculate symbolically because because it is a data crunching software by nature. However, the patches and the toolboxes that I told you already, that I explained to you before, they're going to add extra ability to Matlab. We will benefit that a lot. So let me show you what does symbolic calculation mean and what does it do for us. If I say 1 divided by 2, the result is 0.5. But how about if I need 1 over 2 as a symbolic? Or if I say 3 divided by 9, it gives me this. How about 1/3? Sometimes I need 1/3 as a fraction. And also, when it comes to integration or derivation or limit, most of the time we need the result symbolically as a fraction. For instance, 1 over x. I need it as a 1 over x for simplification purposes, and it's going to be very handy for me. If you remember previously, I told you that you can check the toolboxes installed in Matlab by typing VER, which stands for version, and if you type that, all the toolboxes installed in your computer will appear here. I got the full version, but I didn't have to. It was because I had the ability to get these toolboxes, but we don't need them at all in this course. Some of them are very, very useful, like Statistical toolbox and the Symbolic toolbox. Here we go, that we're gonna learn. So I know that the Symbolic toolbox is already installed in my machine, and you can verify that too. And of course, if you're a student and you've installed the Matlab or on your machine, either you purchased it or you download the trial version, this Symbolic math toolbox is installed already in your machine. If you're a professional working in a company, depending on the version you purchase, it might or might not have that toolbox included. In using Math Symbolic Toolbox, we use SYM and open parentheses. And as you see, it will suggest what kind of variables and parameters you need to use. To show it through an example, to make it more clear, let me do this. 1 divided by half, which was this. Now, if I say symbolic 1 divided by half, you will notice that the result is now in fraction. It's no longer in decimal form. Let's do another one. Let's go symbolic 4 divided by 6. And if I calculate, it will first simplify the whole thing and then get the result. You might think doing something like 1 over half plus 4 over 6, both in parentheses included. So if I do that, you will notice that the result is in symbolic. How about I do this? 1 over 2 plus 4 over 6. And you'll notice that if a symbolic is included, then the Matlab will calculate the whole thing as a symbolic. Because this part is not symbolic, but it's going to be summed up with a symbolic result. Therefore, Matlab does it automatically for us. How about if we wanted to calculate some more complex examples? So if I say CLC, then let's do this. Symbolic, calculate for me symbolically what? Like 4 divided by 6 plus 5 multiplied by cube. Something like that. So I perform a calculation here, and Matlab is going to do it according to order of operations here, and then give me the result symbolically. So if I calculate that, you see that I do have the result symbolically. How about get rid of and calculate the result. So you see that now the result is not symbolically. These are the same thing, but they're in different format. Now, what I want you to do is to look at this variable answer, and especially the format, the square, the yellow square here, while I'm gonna execute the next operation. So what I'm gonna do, I'm going to bring the same formula, the same command here again to this part. So I will bring it by pressing the up arrow twice. It will bring me the command here. And now please look at this icon, and I'm going to hit enter. You will notice that the symbol is also changed, and there is no minimum and maximum information available, and that's because we have calculated this as symbolically, and a symbol does not have the minimum maximum because it's a symbol. So by having a simple glance at this part, you will notice that what kind of variables we're dealing with in this program, and it's very handy. Hi guys, in the last part of the Symbolic Toolbox, I would like to add one more thing which is really important, and it is the fact that we learned how to do calculations in a symbolic format by passing the symbol function into the variable here, answer, so it gave us the result. But sometimes we need to return back the result into numeric, right? Because numeric gives the better sense of precision, and although symbolic is used a lot and commonly in many applications, but numeric is also very, very useful. For instance, to show the example, let me calculate something plus, and then if I pass the symbolic format, you will see that the result created is not actually useful. So if you compare this one, the last one, with the answer here, you will notice that how different they are. In order to return back into that, we use a command called double. So if I say double answer, you will notice that the result is created and I can use that. Also, we learned that we can get more information about the commands through help function. So it is the double, and it will give me more information, what kind of function double is, what does it do, and more information. Also, the DOC or doc double give us the documentation we can read to see what's the nature of that function. And if you notice, I've not talked about it so far, but if you notice, there's a fx thing here, which stands for function. And what it does, if you click on this one, it will give you a toolbar to search stuff for it. For example, if I say symbolic, right? So if I search for symbolic, it will give you the option to search for what you want. So you may go through it and then say, okay, I'm interested in, let's say, rank symbolic, and then it will give you the information. You go hover over it and it will give you further information regarding that. And it's really, really important and handy. Hello everyone. In this part, I'm going to explain more about variables, and it's going to be one of the most important chapters of our course because variables play a crucial role in programming, and we want to make sure that we understand the features and characteristics completely. In order to create variables inside Matlab, we need to observe some rules. For instance, for any variable to be valid inside Matlab, it must contain only letters A to Z, then digits 0 to 9, and it should start with a letter. So I cannot define a variable like 9 times equals 43. This is wrong. It cannot be understood. However, I can say time 9 equals 43. It's completely correct, and I can do that. And also, there is a convention among programmers, and it's that When you wanted to create a variable which is long and it consists of 2 or 3 different words, it's much easier to connect them with underscore. For example, the students in my class. I want to define a variable called students in my class. So I would like to say students underscore in underscore my underscore class. So this is a new variable and I would like to assign a value to it. And also note that x equals 3 is completely different than capital X equals 8, right? Because they're different. If I say x, it's 3. If I say capital X, it's 8. Also, it's a source of many confusions and errors in programs. While some people tend to define variables starting with capital letter and then call that variable inside their program with small letter. While writing your program, make sure that the variables you use inside the body of your program are exactly those that you define at the beginning of your program. So, as we learned, the variables with capital letters are different from those in the small letters. And also, this is a very common source of problem and confusion among early programmers. So for example, if I wanted to demonstrate what I'm saying, I would like to say, let's define time variable as 45 seconds. And then let's go to distance equals to 89 meters. And then I would like to find the velocity. If I wanted to find the velocity, the formula is distance divided by time. And if I type time with a small t, Matlab asks us, I have no idea what's the time. Did you mean time with capital T? And if I say yes, it calculates the velocity. Therefore, it is very important that we call the same variable that we defined earlier. Let's start another one. So let me clear the screen. In this part, I'm going to calculate the area of a circle. So first of all, I would clear all. So I make sure that there is no other variable involved. And in this part, I would use, in this program, I'm using comments that starts with % program. I am going to calculate the area of a circle. Very simple example. All right. The best way to do it is define like the R variable, the radius. Or let's do this. Radius equals, let's say 4. And in this part, I press some space keyboard and then say, this is the radius of a circle. And we learned that this line, because we had a % in front of it, is not going to be executed. But this part is. And you know, this is the best way to make sure we're not cluttering the Matlab screen. And we also know what's the definition. So what is the area? Equals pi multiplied by radius squared. This is going to calculate the area of the circle. So in this part, this line calculates the circle area. If I execute that, it's going to calculate the result. And you see that I do have the area and the radius here. In this part, I would like to show you some features of these windows and how you can get more information out of the variables and outputs that you come up out of running your program. One thing that I would like to show you here is that maybe by mistake or just curiosity, you come here and undock this window, the workspace, right? If you do that, you're going to freak out and say, wow, what should I do now? It's not in place. But actually, it's a way to see the variables in more detail. And you can easily bring it back by ducking back, right? If I duck it back, it's going to come back here. And it's true for other windows as well. The other thing that I would like to say is that if you double click on area, it will bring up something like a spreadsheet. And it is actually a spreadsheet, only with one variable. And it is an extraordinary feature that later that we introduce the matrices and vectors, it's going to be very, very easy for us to first manipulate our data and second do some statistical analysis on it very easily. But here I would like to point out you can easily change the value of everything here by double clicking in this part. So in order to make it more clear, let me double click on radius and the value is 4. You might, after running the program, you might think, oh my gosh, it should be 5 instead of 4. So you can double click on this part and just change that. That's simple. And if you come here, the value is 5. And if I say radius, what is radius? The value is 5. Therefore, it is a place where you can manipulate the data and change it accordingly. We will learn more about it in future videos. Hi everyone. In this part, I'm going to talk about the precision in Matlab and how we can increase that precision when we get the results out of Matlab. So if you had noticed, every calculation in Matlab is going to be reflected back with 4 digits of precision. So in this part, I'm going to show you how we can increase that. Especially in engineering field, there are cases that we're interested in finding the precision in much more detail and just to get a better result. The first item that I want to talk about, we can alter the Matlab precision through a command called format. And by default, Matlab's format is format short, which is 4 digits. And I want to show you how we can increase that to 16 digits. The way that we're going to do it is through format. So if I type format space, and instead of short, I type long. And you will notice that the color is also different. Format long. Therefore, what happens if you do that, when you hit enter, nothing has happened. But from now on, Matlab is going to return the results with more precision. So I'm going to bring back the calculation I just did. And if I hit enter, you will notice that it's now in 16-digit precision. If I say this number multiplied by 889, I'm just making some numbers. You'll notice that now it's in much bigger precision. The way to return back to previous normal calculations is to type format short, which is the default, format short. If I now bring back the calculations that I just did, you'll notice that they're going to be reflected back with 4 precisions. And format makes an important part in Matlab programming, and I'm going to shortly introduce you to different types of formats. So let me clear things. I will use this as a default, this calculation. So the first one was format short, and now format long. The other thing that is important is format short E. Format short E, which is the scientific notation with 4 decimal digits. And if I calculate it, so if I bring the calculation, you will notice that whenever you want that this E be included into calculation, you just pass the format short E into that and it will bring the results into that format. I'm going to bring the longer, this calculation, and I just wanted to hit enter. You will see that the result will contain E exponent. And as you see, it is in 4 precision. And again, if you wanted to increase that to 16, you will type format long E. Previously, it was format short E. And you will notice that now it is in 16 digit and it is in E format. And there are some other parts like format bank. So format bank will give you the result with 2 digits after the point. So let me bring the other one. So it will always give you with 2 digits after the point. Other forms are format short G, which is for floating point. They're not very important, but I'm going to just introduce you to. So format long G. And it's like that. And when I say they're not important, it doesn't mean that they're really unimportant. They have their own place in calculations and engineering field, but in this course we're going to stick with short format and as the standard form and a long format and exponent. Hi everyone, I hope you've been enjoying the course so far, and in this part I'm going to teach you how to do the symbolic calculations, and this time on variables. Okay, so let me clear everything, and also let me get rid of these things. It's just been a while, and we'll learn how to define the symbolic, right? So if I say symbolic 1 over half, 1 over 2, which is the half, now the value is calculated as a fraction, not numerically. But what if I need to do this with variables? I want the variables to be calculated like x cubed, and x is a symbolic. There are two ways to do that in Matlab. The first one is through a function x equals sim, open parentheses. And as you do so, you will notice that the Matlab helps you to complete it. So the first item that I'm going to use, it is single quotation, the variable, and close quotation, close parentheses. I'm going to do that. I will do single quotation, x, single quotation, and close it. When I do that, you will notice that it's now x equals x, which is normal. However, that x is now in symbolic format. Therefore, if I pass x equals symbolic for 9th, so I define a variable symbolically, and I'm going to put it there inside x. If I hit enter, you'll notice that x now is 4 over 9 symbolically, and x is still symbolic. If I say x squared, it will give me the result in symbolic format, and x is still symbolic. How about x cubed? The same thing. So from now on, if whatever I put inside x symbolically, it's going to be treated symbolically as a variable. The second way to define that is through sims and x. So let me use another one, y. The first item that we learned is sims. That the first way was, let me write it again. X equals sim x and this one. This is the first way that we can define a symbolic variable inside Matlab. And the other part is sims x, which is y. I'm going to use a different one here. So if I say sims y, and the second one is also defined as a symbolic variable. And please notice that here, without parentheses, there is an s here, and you can actually create multiple symbolic variables in one line. If I say sims a, b, c, d, e, with one space each, some variables at the same time are created for me, and it's going to be very, very handy and useful. For example, if I use a name, let's say John, let me clear things. If I use a name called John equals symbolic John, and from now on, the John is a variable which is symbolic, and it's going to be used in programming as a symbolic one. There is something very important in this part, and it is when you define a variable, let's say sims y, and you want to store a variable, a value inside this y, which is now symbolic, you must be very careful not to do this mistake that I'm going to show you. If I say y equals 54 and hit enter, you will notice that y is no longer in symbolic. But you might ask, here we had defined it as a symbolic. Yes, but in next line, you again change that. So the correct way to do that is sims y, which is makes it again symbolic, and then y equals symbolic y. Now you will notice that y is calculated as a symbolic and it is maintained as a symbolic format. Hello guys, you might be asking yourself, okay, we understood how to calculate the variables symbolically, but when they're useful and why it's so important. I'm going to show you with a real example. Imagine that I'm going to calculate the area of a circle symbolically. By symbolically, I mean I need to know how many pi's are in there, or what is the impact of the pi on the final value. To do that, I will use sims r as radius and area, because I do have only two variables, sims r and area. But the r is a symbolic, so I make sure that I put it this way. And the value for that is 3/4, let's say. What I'm going to do is put the radius value 3/4. And I want to make sure that it's symbolic. I don't want any numerical results. If I do that, r now is defined as a symbolic value. So I would go and calculate the pi r squared. If I do that, you'll notice that the result is no longer in a numeric format. It's now in symbolic. And I can Hello everyone, welcome to Matlab Programming course. Today we're going to start a new chapter, and the focus will be to familiarize ourselves with new functions which are frequently used in Matlab programming. And these functions are often common between different majors, so they're really important, and we're going to kind of familiarize ourselves with them and learn how we can use them in our project and programming. So let's get started. We all have learned in math classes that the factorial function actually can be activated by this exclamation mark. But not in Matlab. For example, if you type 5 and exclamation mark, and it's going to be like an error there. So in order to use factorial in Matlab programming, what we need to do is to type factorial. As you see, the auto-completion feature comes up, and it's just very intuitive, like factorial n. So we pass the number that we want. For example, if we want to find the factorial of 3, so we pass it as an argument in there and just hit enter. It's 6. We can just try like 6, which is 720, or any number that you like. We need this for the calculus part that we're going to work and cover, especially in sequences. With factorial out of the way, another important function is square root. It's very much used in engineering field, and you're gonna work with it on a daily basis, and so we need to know how to do it. There are actually two ways to get a square root out of numbers. So the first one is using a sqrt. Square root is a sqrt function, and if you pass a number like 9 and hit enter, you see that the number is produced. This is the way that we can get the square root. Let's try another one. Let's go with 49. So this 7. But what happens if we pass something which is not a perfect square root, like 40? You see that the number is going to be produced anyways. Matlab has no problem with finding square root of any number which you can pass as an argument. As I told you, another way to get a square root is through using power and a caret function. If I want to find the square root of, let's say, 9, I can say 9 to power half, which is exactly equivalent to second root of 9, square root of 9. If I do that, you see that the result is produced. Let's go with 81, and the same thing, and also 73, and the result is produced. It is a very convenient way to find the square root of numbers. However, the sqrt function is more common in engineering field. It's good to kind of adopt this notion, especially later when we start programming. It's very useful. Also, I encourage you to investigate more about the square root in here, the Matlab help, and you see that there are different parts and different sorts, so you can click on it and just investigate which part you can use for your programming. Using Matlab's help is a part of learning Matlab programming, and I cannot emphasize this more. Reviewing Matlab's help is one of the best ways that you can master Matlab programming. Now you might think, what if we want to find the third, fourth, or in general, nth root of a number, not just the square root? Well, there is a function in Matlab, and we're going to use that. This function is called nth root, okay? Nth root. And also, let me use the Matlab help system here just to kind of familiarize ourselves with that too. If I say nth root, as you see, if you click on it, actually you might not be able to see it. It's out of my recording area. Let me bring it here. Okay. So the syntax for nth root function is that you retype it like nth root and pass two arguments to it. And the first one is going to be the number that we're searching for. For example, 9, whatever, what a number you choose, and you want to find the nth root, you pass it here. And the second one, which is n, indicates what root you're searching, what's the number of the root you're searching for. For example, you're searching for the third root, fourth root, nth root, whatever, you pass it here. So let's learn it by doing an example. So nth root, I type it nth root, and we need two numbers. Let's go with 27 and okay, so we wanted to find the third root of 27. What is that number? Which, if we multiply it 3 times, we can get 27. So if I hit enter, the result is 3. Okay, how about 81? So you see that it doesn't need to be like the perfect cube root or fourth root. We can totally find any number that you're interested in. So as you see, you can find the numbers very, very easily. Like the square root, we can find the square root of a number let's do this 1/3. And we can use the caret sign for any number that you like. You can definitely get the same result as we get here, but it's kind of not very readable. And also it is very good that we familiarize ourselves with the functions, because it's not like that you always write the program. There will be times when you read other programmers' work and you need to know what functions they've used. So just keep in mind that if you forgot how to use the functions and you didn't remember the syntax, you can always use the Matlab help functions here. And if you just, for any reason, you didn't find it, or you couldn't find it, or didn't want to use that, you can totally just raise the power to a fractional number and get the root. It would be great if we can combine what we learned before with those things that we learned today and practice using Matlab extensively. One of the things that we can do this way is, let me clear up the screen. Let's define a function, a number like 9, and then I can definitely define a new variable and call this QRT of x, and then plus 45, and you see that the result is produced. Or we can do something even more fun, like a QRT of a number, which is going to be a big number, and we find the result. And we can find the symbolic as QRT of the same thing, 89333. Okay, so if we do that, we need one more. The Matlab is going to give us the result in a symbolic format, because we've passed it the symbolic function. We just got the result in symbolic. We can also find the pretty answer. And if you do that, you can see that the results are reflected back in a more like textbook format. So yeah, totally you can just play with it and convert the result in different formats as you like. For example, if you want to find the decimal format, we can go with double answer, and it will just bring the result in a decimal format. So I encourage you to kind of use your imagination and try different things, because that's a very powerful way to learn any new programming language, including Matlab. And meanwhile, you can learn a lot. Hello and welcome back to our next session of Matlab Programming. In this part, we're going to learn one of the most important functions in math and also Matlab programming, and it's going to be trigonometric functions. They're huge, they're everywhere, and as an engineer, you're required to have a very thorough understanding of the sine, cosine, and trigonometric functions in general, and kind of know how to use them in your projects and programming. The good point about trigonometric functions in Matlab is that it's really easy to use them, because we literally type them the same way as we call them. To give you an example, if you want to find the sine of 30, so I can easily find it. Cosine, the same thing. Tangent, the same thing, and cotangent. And these are the basic ones, and there are a lot that I'm going to cover. But to start with, these are the 4 ones that we use a lot. There is something very important when using trigonometric functions in Matlab, and I cannot emphasize this one enough. It is often the main reason why people have unexpected results using trigonometric functions in Matlab. Let me tell you this way. When I want to find, let's say, sine of 45, Matlab by default interprets anything inside the parentheses as radians and not degrees. So this is not sine of 45 degrees, it is sine of 45 radians. If you want to change that to sine of 45 degrees, you need to convert the degree to radians. Because remember that Matlab always, when it comes to trigonometric functions, it always requires that the parameters inside the parentheses should be in radians measured. Before doing that, let me just recap the formulas that we use for converting the radians into degrees and vice versa, because they're important for this session. You already know them, but it's good just to review them here. Now I'm going to convert radians to degrees. Okay, and we learned that if you put a percent sign in front of any line in MATLAB, it's going to be interpreted as a comment. Here we go. Degrees equals radians multiplied by 180 divided by pi. And radians, on the other hand, equals degrees multiplied by pi over 180. Okay, so these two formulas are the ones that we use for converting any number into radians and vice versa. If we repeat that, 45, you see that it's interpreted as radians. So sine of 45 radians is this, but sine of 45, and now I want to convert degrees, because now I want to find sine of 45 degrees. So what I do have here is degrees here. I do have this. And if I multiply this one to pi over 180, the result of the whole thing is going to be in radians, that something which I need. So 45 multiplied by pi over 180 is going to be this one. And if you remember, the sine of 45 is going to be square root of 2 divided by 2. Let's do that just to test our results. SQRT of 2 divided by 2, which happens to be the sine of 45 degrees, is going to be the same as what we found here. So it is really important that we understand this concept. This is a very simple concept, but it happens a lot that while you're doing programming, so you're thinking about a lot of stuff, a lot of parameters you want to do, how you want to define it, and it's really easy to forget about converting degrees to radians and vice versa. And you might kind of think that, okay, sine of 45, but it's not 45 degrees in radians, and you get a result which is either unexpected or different from what you should get, but in worst case you don't realize it because it's a number and it's really hard to find out that it's a valid one or not unless you use some specific techniques. So it's better to prevent that kind of mistakes here, and I want you to just investigate different numbers and functions here so you kind of be confident using MATLAB while calculating trigonometric functions. With that said, let's explore more in trigonometric functions. One important thing that we need to remember in MATLAB is how to do the inverse. In this part, we're going to learn how to do the inverse of trigonometric functions. So we learned the sine of 43, for example, is going to be this one. But when we want to find the inverse of sine, can we do sine of, let's say, negative 145? No, we cannot do that. The way that we're going to do the inverse function is through using arcsine or arccosine or arctangent. And the way that we're going to do it is using a in front of the trigonometric functions, and it converts them into the inverse format. If I say a sine of, let's say this, and it's going to be this number, or a sine of a, let's go with cosine of this one, and you do realize that it cannot be more than 1, right? This one cannot be more than 1. For real numbers, of course, we can go with like a sine of like this one, but it's going to be complex, so we're going to cover later. Here we learned how to use the inverse format of trigonometric functions. Again, the important point here is that exactly like the trigonometric functions that we learn, MATLAB is going to receive in radians and produce the result in radians too. So in case of a sine, let's go with a cosine. A cosine of a number, this number also is going to be in radians, and the result also is going to be the radians. It's really important, as you can see, when we use these trigonometric functions, all we do is dealing with radians, and we're going to convert these radians into degrees. For instance, the last one that we find, a cosine of this number is going to be this, and if I type ans, multiply, now it's in radians, okay? In order to find the degrees, we multiply this radians by 180 divided by pi. If I do that, this is going to be the 53.1301 degrees. Now it is in degrees because I converted the result into degrees, converted the radians. It's kind of important that we understand it here. Let's do an example. If I say a sine of 0.707, okay, so the a sine is going to be this number. Now, if I come and convert the answer multiplied by 180 divided by pi, and as you can see, it's near 45 degrees because I couldn't just make this one a complete number, but I wanted to find the 45. So, if you remember, the sine of 45 degrees is going to be pi over 180. So now it is sine of, what we're going to calculate here is sine of 45 degrees here in this line. 45 degrees is going to be this number. Okay. Now if I reflect back this number, the answer, into a sine, so a sine of answer is going to be this number, and now I convert this one into degrees. So answer into degrees, and you kind of see that now it's a perfect 45 degrees. So I encourage you to work with these conversions, and it's really important that we kind of grasp the idea how we can convert the numbers and radians together. And as you see, we used it for not only the sine functions, but also their inverses as well. Hello everyone. In this very short part, I'm going to cover another part of trigonometric functions, which are hyperbolic functions, and they're really important, but not used very much in engineering. Sometimes you're gonna use it in specific areas. You're gonna use them a lot, but it's kind of good to know how to deal with them in Matlab. So I decided to briefly introduce them here for you, and you can explore them if you need later. The sine hyperbolic is going to be written sine hyperbolic of a number. Okay, so we literally write it the same way. Sine hyperbolic, cosine hyperbolic, and tangent hyperbolic, and cotangent hyperbolic. And as you see, we can just very, very easily calculate all the values, and the rules for radians and degrees also applies here. The next part is how to calculate the inverse hyperbolic. And again, similar to sine and cosine and trigonometric functions, we can type a sine hyperbolic of 39 is going to calculate a cosine hyperbolic, which is the inverse hyperbolic of cosine. So a tangent hyperbolic of 4. And you're gonna just start with different numbers and just explore it, because it's good to know that how we can deal with different trigonometric functions. And also you can come here and type trigonometry, and it just introduces all different sorts of trigonometric functions that you're going to use. And as you see, there are a lot of them. So I encourage you to just go and explore this stuff to kind of familiarize yourself with different capabilities in trigonometry part in Matlab. Thank you very much, and we move to next part. Hello everyone, welcome back to next session on Matlab programming. In this part, we're going to cover one of the most important engineering concepts and sort of functions that we need in different fields of engineering. And that's exponential functions, exponential number, and logarithmic functions, which, as you know, they're used a lot in every field. The first part, we're gonna start by the E number itself. As you know, E equals to 2.718, and we just show it by the letter E. But if you type that in Matlab and hit enter, you see that it's not interpreted as exponential, and Matlab does not recognize it in the same way that we had seen in our textbooks and classrooms. The way that we're gonna learn the exponential in Matlab is through using exp function. So if I say exp1 means exponential e to power 1. If I do that, the answer is going to be 2.718. If we just do that, it means exponential to power 2, or e to power 2, which is exactly equal to 2.7183 to power 2. And this is the way that we're going to interpret exponential. Again, similar to trigonometric function and the conversion of the radians into degrees, this is also very important function. And we're gonna remember how to interpret the exponential. Let me clear up the screen, and next we move to logarithmic functions. The way that we're gonna just use logarithmic is through using log. So log of, let's say, 3. And we get the result. Now, it is very important that this log is a natural log. It's in base E, not 10. Again, in our classroom, in our courses, in university, whatever, when we write log of 3, we almost write log of 3 to base 10, but not here. In Matlab, everything is calculating log of base E, which is the natural log. And in Matlab programming, we need to understand and accept these concepts in order to be a programmer. You know, programmers' words are normally different. So when I say log of, let's say, 5, it is different from log of base 10. It's log of base E, which is called the natural log. That said, but we need also to calculate log of 10. In this part, we're going to cover how we can learn the log of 10. It's very simple and the same way. So we type log of, but instead of leaving it with passing a number to it, we type log of 10, then a number. Okay, so log of 10 of 2, and if I do that, you can see that this number is now in base 10. Logarithm of 10. We can do a lot of stuff to test our results. Log of 10 of 1000. And as you see, we interpret like that. So what number should we take 10 to power 2 so we can get 1000? How many times we should multiply 10 so we can get 1000, which is the answer, it should be 3. Log of 10 of something bigger. Let's do like that, and you see that we can get the result. This is really important, and you can try out different numbers to see how they work until you kind of feel confident about the logarithmic functions and different parts associated with it. And to recap what I just said, I wanted to briefly reiterate what I explained. So when I say log of a number, it is in base 10 that in our textbooks equal to ln. But as you see, if I type ln, it's not known to Matlab, and it's gonna be interpreted as log of 34. It is exactly equal to ln of 34. Okay, so I wanted just to show you what are they equal to if I type this one in Matlab. But the log of 10 is the conventional logarithm function that we learn in our textbook, in our classrooms, and stuff like that. Let's move to next part. Hello everyone, welcome back to Matlab Programming course. In this part, I'm going to start a new chapter, and you might have seen the path that I'm taking you through. I try to familiarize you with different MATLAB functions and what we're going to work with step by step until we're confident enough to start the advanced sections and do actual programmings. So today, let's start a new chapter on complex numbers. I will start by the basics. In our textbooks, we learned that the complex numbers, or the complex part of a number, is known as I. If you type I in MATLAB and hit enter, you're given a number which has a real part with 0 section and imaginary part with 1. MATLAB understands totally the I number as the imaginary part. Something that might be interesting for you is that MATLAB also understands the J. I'm sure you've seen it in many textbooks, and MATLAB is totally fine with that, has no problem with it. So let's do I multiplied by I. So it's -1. As you see, MATLAB understands the multiplication here, and the same with J. With that said, we're now totally fine to deal with complex numbers because we know how to define the imaginary parts. We have already learned how to deal with logarithmic, the sine, cosine, radians, degrees, and stuff like that. But today we learn how to deal with the complex numbers. And this part, with this knowledge, we're now able to deal with a much bigger sort of data and analysis, and there comes a lot of functions which are designed for dealing with complex calculations, and with that we're ready to learn those as well. The way that we're going to define the complex numbers, a complete complex number, is we can do 2 minus 1i. Okay, 2 minus I. It's a totally fine number. It has a 2 as real and 1 as imaginary. And also we can do 2 multiplied by I. Okay, this is a multiplication, so it adds to it. And we also can do I minus 5i. And if you pay attention, I did some calculations which are not normally what MATLAB does, and I explain why. Let me do it this way. If I say, let's define a variable, x equals to 1, the value of x, and if I say 2x, you see that MATLAB gives me an error. And the reason is 2x is not known for MATLAB. The MATLAB is not the normal way that MATLAB interprets the data as input. So in order to do that, I have to type it like this, 2x. 2 multiplication sign and x. If I do that, then MATLAB understands it completely. The reason being is I is just introduced to MATLAB as a separate identity. So if I say 2i, MATLAB's totally fine with that. Minus 5i, the same thing. With that said, let's proceed to complex numbers algebra. So I can do 1 minus 4i. Let me put it in parentheses to make it more clear what I'm going to do. And then plus, open parentheses, 5 minus 4i. So if I do that and hit enter, MATLAB has no problem just doing the calculation. I also can do the same thing and get the same result without putting parentheses, because in this part we didn't have a minus here. But if I do have a minus here, and this is going to be the result, let me choose a different imaginary number here, like that. Okay, so if I do that and there is a minus sign here, if I do the same thing with the plus sign here, of course it's going to be different. This minus is going to be multiplied by different parts inside, but I eliminate the minus bar and hit enter. It is also going to be different. The reason being is now this minus only multiplies to the real part and not to the imaginary part. Just by eliminating here, we have a total story. This minus is going to multiply to all parts inside the parentheses. Because in this course I teach from the very basic stuff, that might be a good topic to explain it. With that said, we are now confident to do the algebraic operations on complex numbers. So let me define 7i. Let me put it in parentheses to make it more clear. And let's do plus 8 plus 7i. Okay, so if I do that, the MATLAB is totally confident calculating the result. I also can eliminate the parentheses here, and MATLAB has no problem with that. And we kind of get the same result because it was just a plus sign between. But if it is a minus sign, we get this result. But if you eliminate the parentheses, the result is going to be different. The reason being is that now this multiplication, in this case, multiplication is negative sign is going to multiply to all parts inside the parentheses, but it's not the case here. It's only going to be interpreted for the real part. So the real parts are going to be summed up together, and the complex points also the same. Now we're going to explore a couple of functions which are designed for complex numbers, dealing with complex numbers, and how we can work with them. Before I further explore this part, I would like to explain the identity I itself. So as you remember, I comes into place when we're dealing with a square root of a negative number. So we had, like, if you had a sqrt of 5, we're totally fine, but if we change that, then a complex number will be created. A sqrt of -1, if you hit that, it's totally equal to I identity. So this stuff, we knew it. Just wanted to give you a brief review about it. Let me clear up the screen. In order to illustrate the multiplication, division, and like taking numbers to power, let me define two variables. Let me define a, 3 minus 1, 3 minus I, and then b equals 7 plus 5i. Okay, so I defined two different complex numbers, and now I can easily do a multiplied b, a minus b, and a divided by b. And as you see, MATLAB has no problem dealing with this type of info. Something which might be new is a raised to the power b. And if you hit enter, you see that MATLAB also can calculate it without any problem, and well equipped with different functions for you, so you can try out different modes. So let me clear up the screen, and now we're going to investigate new formulas that we're going to learn to deal with a complex number. The first one is apps. So if you remember previously, when we have a number, let me define a new one. Let's see, equals to 2, and also d equals to -5. All right, so I defined two new variables. One is positive, the other was negative. Now, if I do apps of d, the result is going to be 5. And what it does, as we know, it just makes this positive. But how about if we type apps of a? And if you remember, a is a complex number. It has a value for real part, it has a value for complex part. So it would be great if, let me do this, if I type a first so you kind of know what we're dealing with. And then if I type apps of a, what it does, as you see, it just returns out a single number. And what it does is that takes the real part, the square of that, and then the imaginary part, raise that to power 2 as well, and adds these together, the squared parts, of course. And then sum them together and take the square. So this one is going to be 9 plus, this one is going to be 1. 9 plus 1 is going to be 10. Then if you take the square root of 10, it's going to be this number. So from now on, we know that if we return a complex number into apps function, it's going to bring us the magnitude of that complex number. The magnitude is the same way if we type angle, of a, so what it does, it just returns the angle between the complex number and the complex part and the real part. And it is the same as trigonometric. It's now in radians. So if you want to try that into degrees, what you're going to do is to multiply this by 180 and divide by pi. So if you do that, now the result is in degrees. This is going to be in degree. Let me clear up the screen. So we learned about the absolute value. We learned about the angle, which defines the angle between the complex and real part. The next one that I would like to talk about is a function called real. So if I type real and say, before that, let me type b here. Now this is b. If I type real b, as you might guess, it will bring only the real part of it. Or real a, if you remember, the real part was 3. The same we can do imaginary. So the function to deal with that is imag. So if I do that, image of b, it will return the 5, and image of a is going to return the -1. So these are some functions that we need. You might ask, why do we need all this stuff? You know, there are a lot of problems that you need only, let's say, the real part to do some calculations. So you want to compare only the real part of two complex numbers, so we can extract them and then compare them, or do some sort of other calculations on the extracted parts. And these are really, really important functions. So let me clear up the screen. And one more function that I would like to talk about here is conjugate, okay, complex conjugate. So if I have a, and you know that the complex conjugate is the same number, but with the different sign for the complex part. So if I say conjugate of a and hit enter, you see that the same thing is returned, what with the different sign. And I can do it with the b too, and it will do that. What could be interesting for you to know is that I can do the same, I can get the same result. If I put b and then single quotation, I get the same result. A was this, and the conjugate of a can be gained that way too. Before I close this part, let me introduce the last one. So there are occasions that you want to create a complex number with a specific part of real and a specific part of imaginary. So the way that we do is like doing this, 4 minus 6i, okay? So I created this way. But if you remember, just minutes ago, I explained that sometimes you kind of extract a part of a complex number and store it somewhere. Extract a part of another complex number and store it somewhere else. Sometimes we bring these together to create a new complex variable. Let me show you how to do that. There is a function in Matlab called complex. So if I type complex and type 3 and 9, it takes 2 arguments. And if I do that and hit enter, you see that it creates the first one. It creates the real, and the next part it just creates imaginary part out of it, adds them together to make one single complex number. These were some few functions that are very common when dealing with complex numbers, and you're supposed to work with these and kind of be confident when using them. See you in the next part. In this part, we're going to further explore the complex numbers and kind of use what we learned so far and try the complex numbers on them. The first one is logarithmic. I wanted to find out the logarithm of a, okay? And before that, let me type a, so we know that we're dealing with a complex number here. So if I say log of a and do the calculation, you see that the Matlab has no problem to deal with that. And it's gonna be easy for Matlab to calculate the results very fast. The other one is going to be exponential function of b. And let me type b here too. Exponential of b, so if I do that, you see that the Matlab returns the value, and this value has a complex part and an imaginary part. You can do all sort of calculations here with complex number as well. So how about the sine of a? The same thing, and cosine of b, the same thing. So you see that you can do a lot of calculations when it's necessary. And so far what we learned it just expands into many branches, and you can try out what you learn in different occasions. Let me clear up the screen. Okay, one of the most important parts that we learned so far is the symbolic math. Okay, so the symbolic toolbox of the Matlab is pretty powerful, and in this part I would like to show you how we can use that too. Let me type A and B here. We know these variables that we defined already, and I can find the angle of A, for instance, and the angle as we know is in radians. But if I type symbolic angle of A, and I literally put this function into a symbol function, and if I do that, the result is going to return like this. It's a very big numerator divided by a big denominator. The reason is Matlab tried to return out the function into symbolic, so always keep in mind that passing symbolic function can return the values not in decimal but in symbolic, and here we were dealing with complex functions. And now what I'm gonna do is to repeat the same thing. So this was A, okay? Now let me define A as 3 plus 3i, okay? So it used to be -1, but now I try to change that deliberately to 3i, and I'm going to explain you why. So if I do that, now it is the new variable. Now if I say angle of A, it's going to return like that in radians. But if I do symbolic angle of A, now look what happens. You will notice that the result is no longer a giant fraction, but it is now in pi format. The reason being is that whenever I define my complex number so that the real part equals the imaginary part, then Matlab can change that, can represent the result as a coefficient of pi. We can really use that. So whenever you have the same real parts and imaginary part, remember that by doing this, you can get the result. As you notice, the result for A with this real and imaginary part was exactly the same when it was a different number but value, because what matters is actually their division, which is going to be the same. Okay, so let me clear up the screen. Now I would like to repeat the same stuff for the functions that we learned, like the apps. Okay, so I do have A here, and I do have the absolute value of A, and now if I say symbolic value of apps of A, and yeah, I typed a B. Okay, so the symbolic is going to return it like that. Pretty ends is going to return it like this if you prefer that. My point is that you can do all of the calculations, all of the functions that I explained before in this part, and pass it to a symbolic toolbox as well to see what would be the result. And also I want to ask you to please repeat the functions that I'm explaining here. And I just wanted to ask you to repeat the functions and the stuff that we're writing here on your own too, because that's the way that you learn Matlab. It's going to be useless if you just watch these videos and not doing some practice or exploring things out of the scope of these videos. Yeah, that would be great, and you will learn much faster. Welcome back. This is the continuation of symbolic calculation of complex numbers. I would like to define a new variable. Let's do it by 3 minus 4i. So I define this one. I wanted to tell Matlab that I want to do calculations on this number symbolically. So if I say sim A, so I tell Matlab that it is a symbolic calculation, and then symbolic of 3 minus 4i. Okay, so I told Matlab to take it like that. And as you see, Matlab reflects back the result in this way. As you remember before, the symbolic toolbox would do the calculations exactly the same they are. There's no decimal or stuff like that. It just deals with everything we pass to it as a symbol. Let me show you how we can do that. So if I type a multiplied by a, okay, 3 negative 4i multiplied by that, you see the results are also reflected back to me symbolically. How about a to power 3? Again, the result is like that, and everything is going to be treated as a symbol. How about the sqrt of a? There is no strange results with the big or small decimals. What it does is just treat them symbolically. To give you a better idea on this one, let's do something big. A to power 4 minus 20 multiplied to a to power 5 plus 12a to power 2. So I did that, and I just kind of make something strange, a result which is not very easy to calculate by hand. You see that the Matlab still tries to calculate everything as a complex and also symbolic at the same time. And these are what we expected to do because we passed the symbolic toolbox to our input. Hello everyone, welcome to Matlab Programming course. Today we're going to start a new chapter which is really important, and I would like to say that from today on we're really into programming, and the concepts that we will learn from today you will frequently see in every Matlab program around you. It is vital that we completely understand these parts and their functionality. We're going to cover a lot of examples on these stuff. The chapters that we already learned are going to serve us very well during these two coming chapters on vectors and matrices. I would like to start by letting you know that Matlab name also came from Matrix Laboratory, which indicates how fundamental the matrices and vectors are to Matlab programming, and it constitutes a great part of Matlab syntax. So let's get started. Vectors are the first identity that we're going to cover today, and they're really important because once we learn how to deal with vectors, it's going to be very, very easy to extend what you learned and implement it on matrices as well. Therefore, you are basically learning matrices and vectors at the same time. So what is a vector? As we learned before, we can define a number and put it to a, like a this one, or b equals to negative 3. But there are occasions that you would like to associate two or more numbers to a single variable. For example, I would like to say c equals for example, I'm calculating the speed of a car as an example. So what is important in our physics problem is that we need to know the distance, we need to know the time, we need to know a speed, acceleration, speed of wind, and stuff like that. You know, there are a lot of factors and parameters that are associated with our problem. And let's imagine it this way. Let me clear up the screen. We have 3 cars that are going to compete with each other. So the first car, I call it A. And what are the important things? I wanted to compare the first car speed to the second car speed to the third car speed. And the same with acceleration of the first car to the second car and to the third one. It will be very hard if I wanted to introduce different variables for a speed of the first car, then velocity of the first car, then the acceleration of the first car. You know, it's going to be very hard to maintain the consistency of the program and just to remember what variable was that. Therefore, the vectors come into play. The way that we're going to define the vectors is using brackets. So if I say A, open bracket, and then I put 1, then space, 2, space, 3, any number, okay? So you can extend it to as long as you want. But let's keep things simple, so when we understand it completely, we can work on the other parts as well. I close the bracket, and if I hit enter, you will see that now A contains 3 numbers and not a single one. And this is something new that we learned today. Imagine that the first one is the distance, the second one is the velocity, and the third one is the acceleration of the first car. Now, if I say B equals 1, 4, and 7, close parentheses. Oh, sorry, I forgot to put equal sign. So if I do that, now B is like that, and I can introduce C as 3 and 1. I just put numbers in it that doesn't make sense in some cases, but it's not important. The point here is I can now associate 9 different values, 9 identities to 3 vectors and just do the calculations. And now it's much, much easier to understand that we're talking about the speed of the car C. So we definitely go to this item. Now we're going to talk about the distance in car A. So we go to this item. And this is the core concept behind the use of vectors. And let me clear up the screen. Another important point while using vectors, these are all the basics, by the way, and we get hang of it as we solve some problems on it. The other important thing that I would like to say that, for example, if I define a new variable, which is in kind of vectors, you're not limited to 3 items, because we conveniently define 3 as to be associated with X, Y, Z, but literally you can go, as you like. There is no limit for you. One way to do vectors is like doing this, right? The same result. I would like to say that you can also put comma between, comma 2, comma 3, comma 4, and you would see that the same result appears. I did that example because there are some textbooks that prefer to put with comma and the other ones not with the comma, just with the space. And so you can do that as well. It is, however, different when we put A equals 1 semicolon 2 semicolon 3. I did that thing the same as above, but now let me add one more to make it like the one above. But here, as you see, I use semicolon instead of comma. So if I do that and hit enter, you will notice that now my vector is vertical. It's not horizontal. And it's really a fundamental concept in vectors and matrices. And we should learn that very, very well, because once we come to matrices and they're going to be algebraic calculations, they're going to be multiplication of the matrices, and it's just a very, very crucial point. Now there are other important parts that I want to emphasize here. So let me clear up the screen. And we have defined variable b, which has 3 parts. Now imagine that it's a vector. You wanted to convert this horizontal vector into a vertical vector. So instead of just retyping it into with the semicolon, what you can do is put b and single quotation mark. And if you do that, hit enter, it automatically changes the horizontal part into a vertical part. And if I repeat the same thing again, answer, it's gonna bring back the same result. Now we have B again. And it's very, very important. Another point which is worth mentioning is, do you remember the car, not this one, let's define it again. 1, 2, 3, 4. As you remember, this was the example of the car that we just explored, and this was like the velocity. Of course, it was 3 items. It doesn't matter. So 1, 2, 3, 4. It's a new vector. It represents some variables. So this might be distance, velocity, acceleration, and the speed of the wind, for example. And now someone tells you, okay, now I am specifically interested in the velocity of the car A. Could you give me that? One way is so you look at it and say, okay, it was a second item, so 1, 2, it is 2. But what if I wanted to extract it and do some calculation on it? I do have like 10 cars and I want to compare only the speed of these cars together. So what we can do is to extract each car's speed and then compare them together, or do some statistical analysis on them. The way that we can extract an item out of a vector is to type the name of the vector and open parentheses to close parentheses. So what it's gonna do is going to extract the second item of this vector, which here it happens to be a 2. So let me make a better example just to make it clear, like 3, -1, 7, 9, 10, 4, -12. So I do have 1, 2, 3, 4, 5, 6, and 7. I do have 7 items in my vector, which is like that. And then someone tells you, I'm interested in your 4th item. So I would say B4. What it does, it extracts the 4th item out of my vector, 1, 2, 3, and 4. How about then the 6th item? So it's gonna be 1, 2, 3, 4, 5, 6. It extracts the 6. That's simple. I would kind of encourage you to do some examples on it and just explore different possibilities and transpose it. Like this, we call it transpose, right? So we convert it into vertical format or vice versa. So I encourage you to do some examples on it and explore it so you can fully understand it. And again, I would like to emphasize it more that it is vital for matrix calculations. See you in next part. Hello again. We're back with vectors, and I would like to give you a practical example here. So let me clear the screen. As you remember, we had a vector, which is the speed of the car, the first car, not the speed, like the data for the first car. So it was 2, 5, 6, and 8. Okay, this was some information about it. And the B equals to 3, 1, 5, 9. All right, so I just made 2 vectors with the same length. And someone might ask you how faster the car A is in comparison to car B. So what you can do, you can come here and say, okay, the 5, this one, the second part was the speed. Okay, it was associated with the speed. And so what I can do is to extract the speed of car A and then divide it by the speed of car B, and then I have the result. So the way I do it, as we learn, we put A2 divided by B2. If I do that, you see that the speed of car A is going to be 5 times bigger than the speed of car B. This was a really simple example to instill the idea. Another important thing that I would like to tell you is the workspace. So far we've used it as recording some data here, but I would like to tell you that there are occasions where you just type a vector and you might say, oh my god, I did the 3rd column, I did it wrong, and you did a lot of calculations afterward, and you didn't realize that this number was wrong at the beginning. So what you can do, instead of just retyping everything, what you can do is come here and double click on it. So it will open as a spreadsheet like document, so sort of like Excel, and then you will realize that the second item here is 5. This is the same vector, by the way. It's A, and this is the same vector. It has 4 elements in it. So if I double click on this one, you will notice that I can change it to, let's say, 8. Okay, and hit enter. Then close it. And then I realized that, oh my god, I did the same mistake for B2. So I come here in B and just type 7. All right, I change it. Hit enter and close it. Now if I do the last calculation again, you see that the result is different. So if I say, let's do it this way, Now I'm going to bring out the A. You will realize that the A now is 8. The second item is 8 because we change it. And how about B? The same thing. It's now 7. So the result will be different also. This is a very handy way that if you ever realize that you did a mistake and you want to calculate again or just revise your calculations, this is a very convenient way to do it. Hello everyone, welcome back to Matlab Programming course. In this part, we're going to learn how to do algebraic equations with vectors. So let's get started. Let me define vector 1, 2, 3, 4, and 5. And vector b equals to be 5, 6, 7, 8, 2, yeah. And then c equals to 0, 9, 6, 2, and 4. Something like that, random. Okay, so I created 3 vectors which has the same length. Now I can do this. I can do a plus b, okay, because they have the same length. What Matlab does is just add element by element. 1 plus 5 equals 6, 2 plus 6 equals 8, 3 plus 7 equals 10, 4, 8, 12, and 5 to 7. So it can add these 2 vectors together. It also can subtract them. It's like that. And also we can subtract b minus a. Okay, so this is going to change the sign, and we can do a plus c, totally fine. And we also can a plus b plus c. So Matlab has no problem with these because it can calculate these operations as long as they have the same length. Now let's try multiply. A multiply c. And you will notice that Matlab gave me an error because the dimension doesn't just match up. And we will explain this stuff in matrix section, but just wanted to give you a short introduction about the vector dimensions, because you might think that you need to do multiplication with vectors as well. So let me clear up the screen. We are able to do multiplication of one element to a vector. So if I do a, which is like that, and I need to, let's say, make every element 8 times bigger. So what I do is 8 multiply a. If I do that, you see that now the results are different. We can choose a negative number, negative 2 multiplied by a, or let's go b. If I do that, it just multiplies negative 2 to each element of b, and b is like that. So negative 2 multiplied by b is going to create negative 2 times of each element here. Hello everyone, welcome back. In this part, I'm going to start a new part in vector calculation, and it is multiplication, a different sort of multiplication in vectors. Well, there are 2 types of multiplication in vector and matrices. One is called dot product, and the other one is a cross product. Okay, so we're gonna start with these 2 first. Let me write down the a again and b, and here I do have 2 vectors which has the same length. This is important, the same length. Okay, now I wanted to calculate their product, and by product we realize that if I do a b, it just gives me an error because we cannot multiply 2 vectors with the same dimension. The way that we can do to kind of find their product, which going to be this one multiplied by this plus this item multiplied by this and continue like that, is a function called dot. There's actually a function dot, and it will ask us to pass 2 values. So one is going to be vector a and the other b. So what it does, it just calculates vector A and vector B together and sum their calculation to see what's the result. When I do that, it gives me one single number. Always keep in mind that the result of dot product is going to be one single number. I can get the same result this way. So if I say A multiply B transpose, okay? A, B transpose. So if I hit enter, it's going to give me the same result. But how does it calculate it? So if I say A, which is this, then B transpose this. Now if we just multiply these together, we get the same result. A multiply B transpose. It will give us the same result as a dot A and B. And it is really important. Okay, so let me clear the screen. Now I'm going to explain about the cross product. And as you know, cross and dot product, which is also known as a scalar product, are fundamental calculations and operations in engineering. And no matter what your field of engineering is, you will need this in your projects, homeworks, or research. Okay, so now we're going to talk about the cross product. Cross product and dot products are very important and crucial calculations in engineering field, and no matter what your major is, you will need them at some point in your homework, in your projects, in your research, and the concept is also important. Here we're not dealing with the mathematics, but I'm going to show you how to use Matlab to just ease your way and get the result faster. So I'm going to create a vector called A, 1, 2, 3, and B equals 5, 6, and 7. Okay, and what it does, oh, I forgot the sign again. Okay, what it does is that the first item represents the X, the second item represents the Y, and the third item represents the Z. And now what we can do is to type cross, and it will just give us a hint, A, and the second item is B. So what we're gonna do is multiply the cross product, use the cross product to do the A vector and B vector. And if I do that, you will see that a new vector is going to be created. So if I say, name it C equals the cross product of this, now a new vector is created. And what is the cross product? It is like when you have an A vector and B vector, the C1 is going to be created in such a way that's perpendicular to both of these. And if you just test that by yourself, you will notice that the result is correct. So this one is important when it comes to finding a vector which is perpendicular to both. There are a lot of applications for this. One of the most famous one is in a probability and estimation theory, where you want to find the vectors which are perpendicular to another vectors to reduce the estimation error, to minimize it as a mean estimation error. Please create some examples for yourself and just try to familiarize yourself with the concepts, with the engineering, with the mathematics behind it, so you feel comfortable when it comes to using them in real programs. Hello and welcome back to next session of the Matlab Programming. In this part, we're going to explore some new functions on vectors, which are really important, especially when used in programming and analyzing data. So let me try out with defining a new vector, 1, 2, 3, 5, 7. Okay, this is my new A. The first item that I wanted to talk about is finding the length of a vector. Okay, there are occasions where you had a large array of vectors and you need to know how many data points are in there. So maybe you want to take the average, maybe you want to just know the number of the data points, or those data represent some specific meaning for you. For any reason, you need to know how many elements are in there. There is actually a function called length. So if I type length and a, because a is my vector, it will give me the number as 5. So there are 5 elements in it. And if I define a bigger one, like 1, 2, 3, 4, 5, 6, 7, 8, 9, and just random numbers. Okay, so I created a big vector, and later I will show you how to do it much faster and in a better way. But for now, we just stick to our conventional methods. So I found a vector that has a lot of values, and it's not intuitive and easy for me to just go and 1, 2, 3, and how many elements are in there. The way that I can do is to use length. Length function is going to go and count it for me and bring it the result. So if I do that, the result is going to turn out to be 17, which is very easily calculated. You can also do some other stuff with the length. For example, I can do length of A divided by length of B. Okay? I can easily do that, and it will give me the result. It might be meaningless at the moment, but there are engineering elements or engineering applications where these are really important. And I will give you one in a moment. Okay, so let me clear up the screen. There might be occasions where you're interested to find the sum of the elements inside a vector. For example, I do have A here. I want to know what's the summation. The way that you can do is to use function sum. I write sum and then open parentheses and type my vector name. When I do that, Matlab is going to go and add all these elements together and return the results, which is very easy. For example, imagine the B. Let me bring the B. It's gonna be a much easier one. Okay, so imagine the B is going to represent the grades of students in a class. You know, it's a terrible class. It has 1, 2, 3, 4 B, and you know, it's just a very, very lazy class. And the teachers just need to know what's the average of the class, okay? The way that we can do is to sum all the values, which is going to be, so the sum turned out to be 134, and then length of B, which turned out to be 17. Then we can find sum of B divided by length of B. All right, so if I do that, it turned out to be 7.8 as the average of the class. And we can do a better way to use the mean function, mean of B, which does the same thing for us. It just goes and finds the average of that vector, which represents some sort of data. The other important functions that we need is the mean and max. If you ever wanted to find the minimum value of a vector, you can do it by typing mean. Okay, so the mean value of A is going to go search the vector A and find all the elements and then bring the minimum one, which is 1. The same one with B. If I do that, it will bring the minimum one as well. And you are able to do some sort of calculations with it as well. How about the max? So the max of A is going to be 7. The max of B is going to be 45. And if this area of data, the B1, if it was representing the temperature, for example, in a refinery or something, and then you're asked to write a program for this refinery to watch the temperature, and if the temperature goes beyond, let's say, 12, then it alarms you, okay? So goes above 9. So even 12 is not allowed. So above 9, it should alarm you. What you can do is to find the maximum value of this vector and watch that value, write a condition for that we'll later explain, and tell Matlab that if this value ever goes above 9, just do these stuff, okay? So this is gonna be some of the functions that they can use, a very simple one. And Don't worry, we're going to learn the conditional programming as well, and I will explain all the sort of stuff to you, so at the end you're fully able to write a functional program. Hello and welcome back to Matlab Programming. In this part, I'm going to show you how you can easily create a vector and also extract some part of a vector. All right. One thing that I would like to explain here is that, as you remember, I can say A equals 1, 2, 3, 4, 5, 6, 7, 8. Okay. I can define A like that. But also, I want to tell you that you can create A like this. So you start 1 colon 8, okay? 1 colon 8, and look what happens. If I do that, you see that the same result is created, and A is also a vector as well. So the first one we created like that, and the result was this. The second one is also another way to create a vector very fast. So if you decided to create a vector, but you didn't want to just type it like that, you can use the colon. But remember that this colon represents that the first item is 1, the last item is 8, and it increments with 1 item. So 1 plus 1, 2, then again 1 added to 2 becomes 3, 1 added to 3 becomes 4. So as you see, the difference between these are all equal, and it is equal to 1. So this is the way you want to do it. But how about if you want to create a vector which jumps 2 steps ahead, not 1 step? So I can do that by B equals 1 colon 2 colon 8. Now I will tell Matlab that start from 1, go to 8, but not 1 by 1, just jump 2 a step. And if I do that, you see that after 1, 2 is going to add it to it, becomes 3. 3 added to 2, 5. 5 added to 2 is going to be 7. So this is another way to create a vector with some specific elements. What is frequently used in Matlab programming is that when they wanted to define time, they say that, okay, let's just start from 0, colon, and go very small part ahead, 0.1, and then colon, let's say 5. And if you hit enter, you see that a lot of columns are created. So if I type T here, you will notice that it's lengthy, and now let's find what's the length actually. Therefore, we come here and type length T, and if you hit enter, there are 51 elements inside the T vector. So these are the new ways that we can define a vector. So you will see them a lot in different programming contexts. So let me clear up the screen. We already learned that if we have a vector like A, and if you're interested in the third element, we can do it by A3. So it brings out the third element for us, or let's do with B. Let's say fourth element. It's going to bring out the 4 part in vector A. But what is interesting to know is that you can extract not a number, but also a portion of the vector. So if I type A equals, now if you tell me I want to extract starting from the second element up to the 5th element, so I can do 2 by 5. All right, 2 colon 5. What it does, it goes and extracts only that portion of vector. I can similarly do 2 to 4. Okay, so it goes and starts from A, 2, 3, 4. It brings out the 3 elements. CLC. Okay. Another important thing that I would like to inform you about is another function called linear space. Okay, so linear space comes from linear space, and if you type it, Let me bring it here if I can. I can't. Okay, so do it this way. Should be able to bring it more help on it. Okay, here we go. All right, so if you type linspace, it will bring the function, and there are two ways that we can do it, like linspace a and b and linspace a, b, and n. So one item has 3 arguments, the other one has 2 arguments. So what it does, linspace, as you come here, linspace a and b generates a row vector that has 100 points linearly spaced between and including a and b. Okay, so if I come here, let me take it there. Okay, so if I say linspace 1 and 10, what it does, it creates 100 points which are spaced exactly equally between starting and including 1 up to 10 and including 10. So if I do that, it just creates 100 items for me, which is linearly spaced. Another one is linspace starting from 1, ending from 10, and like 5. Okay, what does this item, which has 3 parameters, do? This function starts from 1 up to 10 and creates 5 items which are equally spaced from 1 up to 10. So if I do that, you will see that the first one is 1, then 3.2, 5, and 5.5. So 1, 2, 3, 4, and 5. There are 5 items here which are linearly spaced. These are also new ways to define vectors in Matlab. The last thing that I would like to emphasize in this video is that when you extract a part or create a new vector, you're fully able to do some calculations on it, do multiplication, division, or some mean and average thing on it. For example, if I say mean of n's, which is the last result, it's going to give us very easily about it, or length of n's. And the result is, the length of, so let me put this one into a new variable called c, and now I can find the length of c, which is going to be 5. So there are a lot of calculations that you can start working with and practice on it until you're fully confident with Matlab calculations. I hope that so far you've made a great progress in Matlab programming and you're enjoying the class. Thank you very much and see you in next video. Hello everyone, welcome to Matlab Programming course. In this part, I'm going to show you how we can create bigger vectors from existing vectors. So for example, you have some sort of existing vectors or existing data from one sample and the other one also. You want to join them together. How we're going to do that? Let me define 2 new vectors, 1, 2, 3, 6, 9, 10, and 6 again. Okay, this is going to be A, and the B is going to be 3, 6 minus 1, 8, 2, 8, 2, 7, 1. Okay, so we created 2 different vectors which are not the same length as well. And then I define vector 1 equals. So I would say A, and I want to extract from the 3rd element up to 5th element. So let's go 3 to 5th. 3rd to the 5th. Okay. If I do that, vector 1 is created. How about vector 2? Vector 2 is going to be equal to B, but starting from 2 up to 7. Okay, so I created a new vector, which is extracted a part of the vector B as this one. So you know that vector 1 and vector 2 are created, they're part of other vectors, there's some sort of new data, and we're going to combine them together into a new vector. The way that you're going to do that is to call vector 3. So vector 3 is created. Now I put vector 1, comma, vector 2. If I do that, look what happens. Matlab creates a new vector which is bigger, and it consists of vector 1. So vector 1 is 3, 6, 9, 3, 6, 9. Up to here is vector 1, and then 2 to 7, which is going to be 6, -1 here. 6, -1, 8, 2, 8, 2, and it's going to combine it here. We also can get the same result, but transpose it to create a vector which is vertical. This method is used in Matlab programming frequently, and you will see a lot of programs like this. Now we can also add to this one with the fourth vector. So let's call vector 4 equals, starting from, let's go with linspace. Linspace from 1 to, let's go 9, and how many? Let's go with 5. All right, so I created a new vector, which is vector 4, which has 1, 2, 3, 4, 5 elements linearly spaced. Now I want to combine it to the vector I already had. So I go vector 3 equals vector 1, vector 2, and now vector 4. Okay, if I do that and then transpose it, you will see that I added a new vector here. How about the sum of vector 3? Pretty easy. Max of vector 3. Minimum. I just try to review some parts with it together like that. Okay, so it's really easy that you can work with different vectors and combine them to see how they're created. Hello and welcome back to Matlab Programming course. In this part, I'm going to show you how we can do a new sort of vector multiplication, which is really important in programming, and you will find a lot of occasions where none of those types that we already learned, the cross product and the dot product, are going to be useful for us, but this type of multiplication, which is not a formal type but a common one, would be our solution. So let me define two vectors here. Vector A is going to be 1, 0. To show you this example in a better way, I just want to use 0 and 1, like bits and bytes of a computer. Okay, so I create some vectors here. Okay, and the B is going to be equal to 1, 1, 0, 1, 0, 1, 0, 0, 1, 0. Right there. Okay, so I created two vectors. They can be different numbers. They might not be 1, 0 only. You can use whatever number you want to use, but I want just to show you how we can use this stuff here. Okay, so as we learned, we're able to do dot product of A and B, which is a number, and also cross product of A and B. Oh, sorry, we cannot use cross product. I did a mistake here, because cross only is defined for vectors at most 3 items. I just did a mistake here, my bad. Okay, so now sometimes you need to do multiplication of 2 vectors that are 1 by 1. For example, you want to multiply the first element in vector A to the first element to vector B, and the second element in vector B to the second element in vector A, and do it continuously, okay? For example, you had 2 vectors with thousands of length each one, and you want to multiply them together to see what's going to be the result. The shoot here is that these 2 vectors should be the same length. Okay, without it, you cannot do that. The way that you are able to do some sort of calculation is this one, and please pay close attention to what I'm going to do. So I type A, then I type dot, A dot, and then multiplication sign B. Okay, it is something new. So before I do that, let me eliminate the that dot here, and I'm going to hit enter. You'll see that we cannot do that because these vectors are actually matrices. They're not vectors, they're matrices, and matrix multiplication has its own rules and regulations that we're going to observe in matrix section. But for now, let's try it. Let's try to write it this way. So I type A dot star B. Okay, so I calculate this one. Now look what happens. If I hit enter, a new vector is created, and it's lengthy. Let me bring it here. Okay, so the first element is 1 0 1 0 1 0, stuff like that. And if you come here, you will notice that the first element of A and B, if you multiply, is going to be 1 here. The second element, because one of them is 0, the result is going to be 0. The third one, the same. If you follow the pattern, you will notice that we did it. We could divide, we could multiply each element by its corresponding element in another vector. The same way, we can do this by division. So now you're able to do the division, and you see that there's a non-applicable because it's going to go infinity. All right. The point here was that you are able to do the multiplication element by element in a list when you use the dot before the operation. So this is kind of important. We need to use the dot sign before the operation. Either it's division or it's a multiplication. We're going to use that before. So A dot division by B, and you will see that the result is going to be created. Hello and welcome back to Matlab Programming course. Today I'm going to teach you how to do basic statistical analysis on your data in Matlab, and I wanted to tell you that Matlab has a very powerful statistical toolbox installed, and you can read the help manual and just use the statistical analysis if the statistics, economics, and stuff like that is your major. But even if you're an engineering student, you occasionally need to, not occasionally, actually frequently, you need to work with the statistical results of the data that you derived, and you need to know the relationship in your set of data, both as data validation and also finding the accuracy of your data. So today we're going to cover some basic statistical analysis here. So let me clear this thing, and let me define a new variable called, let me call it data, equals 10, 23, 89, 40, 3, 87, 64, 12, and 49. Okay, so I created a set of data. Now I want to find the mean. So as we know, the mean of data can be calculated as using the mean function easily. How about the median? So the median can be found with the median function, like that. very easily. One of the other important functions in a statistical analysis is the standard deviation. So STD is a function that we use to calculate the standard deviation. So standard deviation of data will be calculated with STD. Another one is variance. The variance of data equals 977.55, and as you know that the square root of variance, so SQRT of variance of data is going to be exactly like the standard deviation. So if you calculate the variance and take a square root of that, it's going to be standard deviation. Here, I'm not going to go after mathematics behind the statistical analysis and all these values, what are the mean, what are the variance, but I'm going to show you how you can find these parameters if they're important in your engineering project or homework. Again, I would like to emphasize that please don't forget to use the help of the Matlab. It is one of the most amazing sources of learning Matlab, especially when you can copy paste examples there and just verify your theories this way. Thank you very much and see you next video. Hello everyone, welcome back to Matlab Programming course. In this part, I'm going to show you one of the most important subjects in our course, and it is creating vectors with random numbers. All right, first, before we get into vectors, it's better that we ease our way into random numbers and random functions through scalar cases. So if you want to calculate a function which has random elements in it, the way to create one is through using rand function. Okay, so if I type rand and hit enter, it will create a number for me. How about if I do it again? You will see that the result is different. Each time that you typed rand and do it again, you will get a new result, and that's the way it's designed. We're telling it to give us random numbers. Let me clear the screen. We're going to extend the same thing into vector concepts. If we need a vector with random functions, we can open parentheses, and Matlab gives us some examples how we can do it. Rand n and rand mn, and if you type help, it will give you how we can do it. So rand of n returns an n by n matrix containing something that we're gonna cover later, but the rand m and n is something that we're interested at the moment. So what it does, I encourage you to read it thoroughly so you can get the most out of it. But for now, the rand, it accepts two parameters. The first one, I type 1, and the second one, let's go with 8. Or no, not 8, 4. Let's just start with something small. Rand 1 and 4. Let's see what happened. If I type it, it creates a vector with 1 row and 4 columns or elements. 1 row, 4 columns, 1, 2, 3, 4. Okay, so if I do the same thing again, you will see that now the numbers are different. How about now? Different, different, and different. So the same way that the rand function created scalars which are different, the rand, when defined for vectors, is also going to create new and unrepeated values and vectors. So let me clear up the screen. I can also do 2 multiplied by rand of 1 to 5. So if I do that, and before let me do rand of 5 so you can see what's the result, and then if I make 2 times of that, it's going to create it seamlessly for me. The sign of rand of 1 and 3, 1 and 4 is going to be created as well. Okay, so any functions that we learned so far is going to be applicable here too. Now you might have guessed that what happens if I go with this one and change this one to 2? Well, you can have a sneak peek of that and you will see that it's going to create a matrix, and we're going to work with that in coming sessions. But you have guessed that rand is actually a fast way to create a matrix. Let me clear the screen. Occasionally, you might be asked to create some vectors with unrepeated numbers, okay? So if you want to create something which you're sure there is no repeated items in that, for example, you want to draw a winner, okay, out of that box or out of that number, and you want to just have only one winner. And someone comes to you and say, hey, could you write me a program that can generate, for example, 2 million numbers for me, and these 2 million numbers should not be repeated. And the way that you're gonna do that is through a function called randperm. Randperm. What randperm is, if you remember in probability, there's a permutation and combination. So the permutation is where when you have different options which cannot be repeated. So each one of these options should be unique. But in combination, you're fully able to do that. You can have repeated items. Here, I type a number like 5. And if I hit enter, you will see that 5 numbers are created, which no one is the same. If I do that, not the same, not the same, and not the same. Another part that we might need to work with is when you need a vector which has all ones or zeros. Okay, occasionally you might need only a vector which has ones. All right, so ones, if I do that, it asks me how many you need, and I will say 7. If I do that, it just creates, this is for matrices, my bad, ones. So if I go with that, I should select 1 and 3. If I do that, you see that the results are created. The ones that we had here also used in matrices a lot, and we will cover all this stuff later. But for now, just remember that if you wanted to create a vector, because this chapter is dedicated to vectors, I want to give you examples that are only for vectors. But you can just extend that to anything, just explore everything you see here. My advice to you is that just explore everything that you learn here and try to make things different for yourself. Explore that what happens if I do this parameter, I change it like that. Okay, and we do also have zeros of 1 and 5, for example, and it will create for me, or zeros of 1 and 3, and I do that. It might be hard for me to explain where do you need this stuff, but my point here is to show you how you can generate and automate your work rather than sitting down and create like rows with 100 items. And when we get into programming section, I will show you a lot of examples that you can, that these functions come handy, and you can explore them by yourself. One more function which is handy sometimes, and you might have used it in Excel, is the sort function. So let me clear the screen. Randperm. I'm just going to create a random permutation of, let's say, 5. Okay, I created that. Now I want to sort it in a way that it's in ascending order. So if I say A equals sort of before doing that, let me do it professionally. I create a function called a variable called a, and then I create a new one called b equals to sort of a. Okay, and if I do that, you'll notice that now it's created 1, 2, 3, 4, and 5, which is in ascending order. Hope you used the functions along with me and learn how to combine them as well. See you in next video. Hello and welcome back to Matlab Programming course. Today I'm going to teach you how to do basic statistical analysis on your data in Matlab, and I wanted to tell you that Matlab has a very powerful statistical toolbox installed, and you can read the help manual and just use the statistical analysis if the statistics, economics, and stuff like that is your major. But even if you're an engineering student, you occasionally need to, not occasionally, actually frequently, you need to work with statistical results of the data that you derived, and you need to know the relationship in your set of data, both as data validation and also finding the accuracy of your data. So today we're going to cover some basic statistical analysis here. So let me clear this thing, and let me define a new variable called, let me call it data, equals 10, 23, 89, 40, 3, 87, 64, 12, and 49. Okay, so I created a set of data. Now I want to find the mean. So as we know, the mean of data can be calculated as using the mean function easily. How about the median? So the median can be found with the median function, like that, very easily. One of the other important functions in a statistical analysis is the standard deviation. So STD is a function that we use to calculate the standard deviation. So standard deviation of data will be calculated with STD. Another one is variance. The variance of data equals 977.55, and as you know that the square root of variance, so SQRT of variance of data is going to be exactly like the standard deviation. So if you calculate the variance and take a square root of that, it's going to be standard deviation. Here I'm not going to go after mathematics behind the statistical analysis and all these values, what are the mean, what are the variance, but I'm going to show you how you can find these parameters if they're important in your engineering project or homework. Again, I would like to emphasize that please don't forget to use the help of the Matlab. It is one of the most amazing sources of learning Matlab, especially when you can copy paste examples there and just verify your theories this way. Thank you very much and see you next video. Hello everyone, welcome to Matlab Programming course. Today we're going to start a very important chapter in our class, and it's going to be about matrices. Well, they're so important that chances are you already work with a wide variety of them through your classes or the projects that you've worked. And in addition to that, they're going to be also very important for Matlab itself, because the Matlab name comes from Matrix Laboratory, which further indicates how important and fundamental matrices are to engineering field. So it's necessary for us to equip ourselves with proper tools and knowledge to deal with them in our career. Fortunately, in vector chapter, the previous one, we learned a lot about matrices at the same time, because matrices are the vectors in bigger dimensions, and all those techniques that we learned in vector chapter are going to be applicable here, either directly or with a slight modification. So let's start learning matrices. Let me do a short recap on vectors that is going to ease our way into matrices. So we already learned that we define vectors. Vector 1 equals to, let's say, 2, 6, 8, 0, just random numbers, and 1, -1. So I was able to create a vector like that, and if I needed to extract, let's say, the fourth element, what I need to do is just type vector, the name of the vector, vector 1, and the fourth element I put it inside a parentheses, and this way Matlab understands that we're interested in 1, 2, 3, and 4. So this was the way that we introduced vectors and extracted the elements. Now we're going to learn how to define matrices. So if I type matrix 1 equals, I open the bracket, and like vectors, I put numbers like 4 and 2 and 7. First, let's create a 2 by 2 matrix. So 4 through, and now I need to tell Matlab that, okay, this was the first row. I need to go to the second row and complete this next set of information. The way that we do is through putting semicolon. If I put semicolon, as we learned in Matlab, it means we're telling Matlab that, okay, it's done, go to the next line. The same thing happens here, but I don't close the bracket to tell Matlab that that was the end of the information and data. What I need instead is put the second set of data here, and now that I do have a 2 by 2 matrix, I can close the bracket and hit enter. And as you see, we easily created our first matrix in this course. This is going to be a 2 by 2 matrix. Similarly, we can create 3 by 3 matrix. Matrix 2 equals 1, 3, 7. Next line, 4, 8, 1. And now the third line, 9, 5, -2. And close bracket. Now I do have 3 independent set of vectors, 1, 2, and 3. So if I hit enter, if I hit enter, as you see, now we've created a 3 by 3 matrix. We're not, though, limited to creating square matrices, and we can do like that. Matrix 3 equals, now I want to create a 2 by 3 matrix, 2, 5, 8 for the first row, and then 4, -2, and -1 for the second row. And if I hit enter, now you see that it's perfectly fine, and we created 2 rows of 3 columns. And I urge you to go and create larger matrices and explore typing and creating them, because it helps you to deal with many more functions that relates to matrix calculation further in this course. Similar to vector element extraction, now we're going to extract elements out of matrices. So let me clear the screen. I wanted to create matrix number 4 equals, let's create a 4 by 4 matrix. 1, 2, 6, 7, 3. I just randomly put numbers here. 2, and then 9, 6, 1, 0. And the fourth row is going to be like that. Okay. So I created a 4 by 4 matrix, and now let's say I am interested to extract this one. Well, in vectors, we were able to just tell Matlab that go to the second one or extract the fourth one, but now we do have 2 factors or indices to point to a specific element into a matrix. And now if I type matrix open parentheses, matrix 4, open parentheses, and let's say we're interested into this 6. So 6 is going to be not first row, not second row, but the third row, and first column, second column. So it's going to be third row and 2, and the second column. So third and 2, because we need 2 indices to point out to a specific element inside a matrix. And if I hit enter, so MATLAB perfectly knows how to extract that specific information out of a matrix. And always remember that in math on paper, in MATLAB also, we first refer to the rows and second to the columns. The next example, let me extract this one, or maybe this one, number 2. Okay, so if I want to extract that one, it's going to be in the second row and the fourth column. So if I hit enter, I can get this element out of matrix. Let me show you what happens if I put only one index here, one number, like the vectors. You know, we had vectors and we put one element because they were just one set of information. Now if I do that, MATLAB doesn't give me an error. Instead, it returns a number. And if I look at this matrix, I can see that the 1 is the first element. So let me go to 2, matrix for 2. If I hit enter, now it brings -8. Interesting. If I keep doing that, it brings 9. So I understand that by doing this, MATLAB presumes that this is the first one, second, third, fourth, and just give every element a numerical number starting from here and then going to second column and third column. And MATLAB just deals with that like the way that I showed you. It's not very useful or important, but it's good to know that how matrix maps the information and data. Please practice the information that I just showed to you, because then you feel confident typing matrices and do matrix manipulation and other algebraic functions that we're going to learn. See you in next video. Hello and welcome back to Matlab Programming course. In this video, we're going to explore how we can extract range of information out of matrix. So if you remember in vectors, vector 1, let me bring up the vector 1 we worked with. If we wanted to extract a range of information, we could do it like vector 1 equals, let's say we were interested from the second column to the fourth column. So I would simply put 2 column 4. So if I do that and hit enter, MATLAB just extracts this information because I told MATLAB to extract from the second column up to the fourth column. But how about the matrices? Because matrices do have 2 dimensions. And let me bring up the matrix 1 I work with, or matrix 4, I guess is better. Okay, so now if I wanted to extract information, I do have 2 dimensions and I need to specify exactly what I'm pointing to MATLAB for every single dimension. The way that we do that is like, let me call it A equals matrix 4, and now I want to extract, let's say, a part of it. Let's start from the middle part. So I'm going to extract this square matrix, so 9, 5, 6, 1, because I was interested into extracting a sub-matrix out of it. And did you remember that it showed you when I wanted to extract information like the vector, we separate the extraction element by column. And this was due to the fact that we had only 1 row, so we didn't bother to put it here. But here at matrix 4, I need to specify exactly where I'm pointing at. And if you wanted to point out to these submetrics on paper, the normal way that we can do is that, all right, so the first element of this submetrics starts from the second row and ends at the third row, right? Because we always deal with rows first in Matlab. So it starts from the second row and extends up to the third row. In terms of columns, it starts from the second column up to the third column. So we put it like that. First rows starts from 2, ends to 3, comma, because we're going to extend to the columns right now. So the rows 2 up to 3 and columns also 2 up to 3. And if I put that and hit enter, now you see that Matlab extracts just the middle part. Let me give you another example. B equals matrix 4, open parentheses. Okay, so 7, 3, 5, 2. Okay, we're interested into this submatrix. And if I want to do that, first I deal with rows. It starts from the first row and extends to the second row. So first up to second. Now we're dealing with columns, comma, and come here. It's third up to fourth column. So third and fourth. And you see that it easily extracts a set of information. What happens if you wanted to extract just this section row? Okay, the rows, we do have 4 sets of them, but we're interested into only starting from, let's start with this one. 8, 5, negative 1. Okay, 8, 5, negative 1. The way to do that is, again, let me call it C and call it matrix 4, open parentheses. And because now we're only dealing with one row, and it starts from the 4th row and ends on the 4th row as well. So the way that we do is call 4 here, comma. And it indicates that we're only dealing with the 4th row. And in terms of column, it starts the second and ends on the 4th. So second up to 4th. And if I do that, Matlab perfectly extracts this set of information. To do another example, let me call matrix 4 again. And now we're interested to extract negative 8, 9, 5, and this 3 by 3 matrix starting from here. So the lower quadrant here, this part, a 3 by 3 matrix. I wanted to extract that. So again, it starts from the second row up to 4th row. And in terms of columns, stop 1 up to 3rd. That's simple. So if I do that, I can easily extract information out of this. Let me clear the screen. Okay, we'll learn how to create matrices. We'll learn how to extract information out of matrices. But sometimes we need to just change the values in matrices and just manipulate the values. One way to do it is to, let me call it like matrix 1. So if I double click on the workspace here, as you see, if I double click on it, and I mentioned that before, that you can just manipulate the data. For example, I remember, oh, it was not 4, it was negative 4. So I put negative 4 here and hit enter. And if I just close this part and type matrix 1 and hit enter, now you see that the new value appears here. That's a very useful and powerful and fast way of changing the matrix values. And even I can add 5, 6 and 5, and then I can even extend that 7 and 8. Let me add another row too. So 5, 0, 8, and negative 124. Okay, so I extended matrix 1 into newer dimensions. So if I do that, and you see that the new values appear here. It's very, very handy for those people who are more confident in Excel-like interface for inserting the value into Matlab. However, I encourage you to do it manually here, because the more you type, the more you program in Matlab, the more you feel confident learning it. And, it has a learning curve that is going to be shortened by practice. And one of the best ways to practice correct programming style is to type it over and over again. With that said, I see you in next video. Hello everyone, welcome to Matlab Programming course. In this video, we're going to start trying algebraic functions on matrices. And because we deal with these sort of functions on a daily basis and in our calculations and projects and stuff like that, it's very important to learn how to work with them efficiently. So let's start with the summation. Let me create a matrix called A equals, let's do it 2 by 2. 1, 2, and 3, and 4. Okay, I created a very simple matrix, and let me create another one. 5, 6, and 8, 1. Something like that. Very good. Now I do have two matrices, 2 by 2, and now I wanted to add them together. As with the vectors that we learn, in order to do algebraic functions on matrices, they need to be the same size. If you remember, we couldn't sum two vectors which had different dimensions. The same is true with matrices. With that said, let us add A and B. If I do that, Matlab easily adds the first element of A to the first element of B, and then it creates the summation here. So 1 plus 5, 6, then 2 plus 6 is going to be 8, and bring it here. And the same for the second row. Very simple concept. Okay, so next let me do the subtraction. And again, it's very, very similar to addition. And actually, it is some sort of addition, because the way that Matlab actually performs this operation is to multiply B matrix with a -1 and then adds the A matrix to that new B matrix. Let me clear the screen. We can also create a 3 by 3 matrix. So 1, 2, 3, 4, 6, 0, 7, 1, 4. So this is a new matrix. And let me add another one too. 6, 5, 1, 9, 0, 9, 0, 5, and then go with 8, 2, 5. Something random. I think I made a mistake here. Okay, so if I do that, now I do have two sets of 3 by 3 matrices. Now I can add them, C plus D, and also C negative D. I can easily do that, but I cannot do the same with A plus C, because they had different dimension, and Matlab is trying to tell you that matrix dimensions must agree in order to do that. Let me clear the screen. Now let's try to do the multiplication. Let me bring up the matrix A. So I can type any number like 4 multiplied by 2, by A, and Matlab just performs the operation, or -1 multiplied by A. Very, very easy. And even we can do the same with constants, like pi multiply A. So a new matrix is created. The way the Matlab performs is to multiply this constant value into A matrix and just get the result. We can do the same with B as well. So let's do C. We can do C multiplied by 1/4. So any constant is just valid, and we can do that. And we can do a SQRT of a big number like that, then multiply by pi, then multiply by -3. Let me do it symbolically. Symbolic -3 over 9, not 9, 8 is better, and then multiplied by d. So if I do that, Matlab easily just performs the operation and just return it symbolically like that. So my point is that you can do all sort of information and just create what you want. And if I wanted to change that, I can do double ands. And now, so we put home. You might ask, how about the complex numbers we learned? So one of the main goals of this course is to use whatever we learn in future chapters as well. So I think it's a good point to just practice the complex numbers in matrices as well. Let me bring up the C matrix like that, and I can easily type I, which is a complex number, only the imaginary part, multiplied by C. And every element in that is going to be a complex number. And I can also multiply 3 minus 8i, then multiply by, let's say, C. And if I do that, now all the elements in matrix, the new answer is going to be a complex number. And Matlab has no problem because it deals with the whole complex number as one single constant and multiplies it to the whole matrix C. This is one of the points that you can double click on answer here, and if your matrix is complex or it's a big number, it's easier to just manipulate it here instead of just doing it directly in Workspace. So I can do like turn this one into -12 and this one to 5, and if I do that, I can return the ants, and now you see that it's now turned to -12 and this one to 5. In this part, we'll learn how to deal with matrix algebraic functions, and please do some calculations yourself, create different matrices, and like use hyperbolic function, trigonometric functions, and just mix it with complex numbers, show the result in different format, and just try to familiarize yourself with different concepts throughout this course, and that's one of the best ways to learn Matlab. Also, I would strongly recommend that each part that I teach you, you open up the Matlab help and explore further what examples are available there and what can you learn from those examples. Chances are you learn a new function that will help you to create better and more efficient results. Thank you, and I see you in next video. Hello everyone, welcome to new video of Matlab Programming. I'm Hossein Tutunchi, and today we're going to learn about matrix multiplication, which is one of the most important functions in this chapter. So as we know, with matrix rules, matrix multiplication rules, the only way that two matrices are able to be multiplied together is that their dimensions should match. And let me show you by example what do I mean. So let me create a matrix called A, which is 1, 4, and 6, and -1. Okay, a 2 by 2 matrix. And let me create another one called B, 0, 6, and 4, and -1, -7. Okay, so I created two matrices A and B, which happen to be 2 by 2 as well. If I multiplied A and B, Matlab just simply multiplies them together and returns the result. But why is that? The reason was the dimensions of A matches that of B. If you remember, we could get the dimension through a function called size. So if I put size A, it turns out 2 by 2, which means that there are 2 rows and 2 columns to it. And how about the size of B? And it's 2 by 2. The only way that 2 matrices are going to be multiplied together is that the columns of the first matrix is going to be equal to the number of rows of the second matrix. That's the only way that we're able to multiply 2 matrices together. Let me clear the screen. Now we're going to define a new matrix called 1, 2, 3, and 4, 5, 6. It's a 2 by 3 matrix. And now we're going to define a new one. D equals 3, 5, 8, 9, and -1 and 0. And as you see, we can find the size of C, 2 by 3, and the size of D, 3 by 2. And if we multiply together C multiplied by D, because we do have the same rows and columns of these 2 matrices, when multiplied together, the result is going to be, first of all, it's going to be possible to multiply these 2 matrices, and then the result is going to be a 2 by 2 matrix. So if I do that, you see that Matlab easily performs the calculation. Let's do it this way. How about D multiplied by C? Well, if I do that, the D, which is the size of D, is going to be 3 by 2. And the size of C is 2 by 3. And as you see, 2 does not match. Let me calculate the D multiplied by C and see what happens. If I do that, you see that because the columns of D equals that of C, the rows of C, it's still going to be possible, and the result is going to be 3 by 3. How about if I create another matrix called 2, 3, 4, 6, 7, 9. Okay, so how about I create this one? Let me, it's the same. Let me create, yes, this one is better. Okay, so I created a new matrix called E, like that. Do you think I'm able to multiply E by D? So if I do that, you see that it's not possible because size of E is 3 by 2 and size of D is also 3 by 2. And when we multiply together, they do have the same size, but when we multiply together, this number does not match to this. So this is the number of the columns of the first matrix, and this is the number of the rows in the second matrix. They should match together so we can multiply them. And therefore, it's not possible here. So in this video, as a summary, in this video, we'll learn how to multiply 2 matrices together and what's the condition that makes it possible so 2 matrices can be multiplied together. It's very important, and it also happens to be one of the main reasons why people receive errors while doing the multiplication. It's the most frequent reason. So please make sure that you understand the logic behind the matrices, how we're allowed to do multiplication. With that said, I see you in next video. Hello everyone, welcome to new video of Matlab Programming, and in this session we're going to explore more the matrix multiplication function, because it's very fundamental to engineering field and data manipulation. With that said, in previous video we learned how to do the matrix multiplication, but there are times when you need to multiply matrices element by element. And if you remember, we covered this feature before in vectors, but because it is important, let's explore that here in matrices as well. Let me start by giving you an example. Imagine that we have a class of 16 students, and we wanted to record their presence in class in 2 days. So the first day, we want to see from these 16 students how many were present. And on the second day, we wanted to see how many students were present on the second day. So if the students are present, we indicate that by 1, and if they're absent, we indicate that by 0. Therefore, let me create the class. So I call it class equal class first day equals 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, and the last one 1, 1, 1, 1, 1. Okay, so the class first day, it means that the first student was present, the second one was present, the third one was absent, 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 this way. So this is the first day presence matrix. And the second day, we call it class second day equals 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, and 1, 1, 1, and 1. Okay, so this is also the class on the second day. So the students were like present that day as well. Some students were present and some were absent. Now what we want to do, we want to see how many students and which ones were present the first day and the second day. We know that if we multiply these two matrices, let's do it actually. So the class first day multiplied class second day. If we do that, you see that it returns a very different result because it just performs the routine and the normal multiplication of matrices. What we are after though is multiply these elements, these matrices, element by element, so we can see which ones were absent and which one were present, because 1 multiplied by 1 is going to return 1, which indicates that the same student, because this one is exactly the same student as this one. So this way we can understand that which students were present and which students were absent. In order to do that, we need to do the multiplication element by element. So the way that we do that is by, let me clear the screen first. So we can say class, or I can double click it here. So the class the first day, the class the second day. Okay, so I return these. And now what I do is class first day dot multiply. If you remember, putting dot before the algebraic function makes that into an element by element multiplication. That's something that really we want. So class second day. So the class second day, and we put dot in multiplication. Now if I do that, you see that the result now shows that the first student were present the first day and the second day. And we can just see that these students were either present the first day or the second day, but not both. This type of multiplication is not as frequent as the normal multiplication, but there are times in engineering field that you need to perform such activities, and it's good to know that you're able to. Let me clear the screen. The next example that I'm going to show you is very useful, and there are a lot of times that you need to perform this operation, and I feel that it's a perfect time to explain it. What we're going to do is to find the summation of all elements in a matrix. If you remember in vector, let me create a vector called 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I created a vector with 8 elements. And if you remember in vector chapter, we learned that there is a function called sum. And what sum does is when you pass a vector into it, what it does, sorry, I misspelled it. So if I return the name of the vector into some function, what it does, it creates a single number which happens to be the summation of all elements, right? Okay, how about when we have a matrix? So let me create a variable called matrix and put a matrix in it, 1, 2, 3, 4, 5, 6, and 7, 8, and 9. Okay, so I created a matrix 3 by 3 matrix, and I need to know how to find the summation of all elements. Let's try the sum function here and see what happens. If I say matrix, and if I pass that, you see that we only have, and as you see, we don't get one single number. Instead, we receive 3. And if we look closely, we see that this 12 is the summation of 1, 4, 7. This 15 is the summation of 2, 5, 8. And the same with 18. So what Matlab did here is to return the summation of all columns respectively. So the sum function did not create the same result as vectors, and that's normal because we're not dealing with vectors, we're dealing with matrices. But there is interesting result here. If you look at if you pay attention here, if you look closely, you see that the answer now is a vector indeed. We didn't get a single number as here, but we received a vector, and the vector is summation of all columns. What we can do is now sum these 3 numbers together, right? Because we do have a vector here. So if I put sum ands, if I do that, you see that now I received a single number, which is the summation of these 3 numbers and also the summation of all elements here. Therefore, a shortcut to do that is to use sum twice. So sum, and again, sum of matrix, right? Now, and another, okay. So now I do have a matrix, the variable called matrix, and it is a matrix indeed as well. So what I do is to pass summation twice, and look what happens when I hit enter. The result is again 45, the same as the one that we received here. So what I wanted to explain here is that if you want to find the summation of all elements in a matrix, maybe it is 1000 by 1000, you cannot just use a calculator or or type them one by one and then do the summation again to do this. Summation again to find the last result. What you can do is to use this function and find the total summation. Let me clear the screen and give you another one. So I call it A, 1, 2, 3, 4, 5, 6. 5 is good. So 5, 6, 7, 8, and 9. And 4, 5, 8, 1, and 0. Okay. Now I created a matrix which happens to be 3 by 5. Now if I wanted to find the summation, one way is to do the the way that we learned was to do that summation twice. So if I simply pass A into two summations and do it, the result is going to be 68. And if you do it by a calculator out of Matlab, you see that the result is always, that it is indeed the correct answer. With that said, I see you in next video. Hello everyone, welcome to Matlab Programming course. I'm Hossein Tutunchi, and today we're going to learn how to find the minimum, maximum, and number of elements inside a matrix. If you remember, in vectors chapter, we learned that if we have like a vector like that, and if you're interested to find the minimum value among these numbers inside this vector, what we can do is to pass the vector, the name of the variable, to into mean function. And what it does, it just finds the minimum value among all these numbers. And the same was true with max. So if I say max vector, what it does, it finds the biggest, the largest number in this vector. But what if we have a vector, instead of vector, we have a matrix? But what if instead of vector, we have a matrix? So let's create one. What I do is, let me come to the first line, and I define a matrix called A. And it's going to be 1, 2, -4, 6, and 8. And the second row, -9, 0, 12, -85, 9. And the third row, let's go with 102, 6, 9, -23. And one more, 76. Okay, so I created a matrix which happens to be 3 by 5, and now I'm going to find the minimum value among these numbers. If I pass the matrix A into minimum function and hit enter, you see that a vector is created, exactly like the sum in previous video, that the first number is going to be the minimum of this, the first column, and the second one, the second column, and just the vector that we found here is going to be representative of the minimum columns of matrix A. But what if we need to calculate the minimum, and actually not calculate, to find the minimum value inside matrix A? What was the solution when we faced the same problem with summation? We learned that if we pass the summation twice, we can find this, actually the total value of the summation of the whole matrix. Therefore, here also we can pass the minimum twice. So minimum of A, what it does, it first calculates the minimum vector, which is going to be here, and then inside the second minimum, which is here, is going to search through this vector and find the minimum value. And let's see what happens. Sorry, it's the capital A. So if I do that, the return value is going to be -85, which is correct, because if you look at this matrix, you see that the minimum, the smallest number, is -85. How about the maximum? If I say max and max A, do it twice, it goes and searches the whole matrix to find the largest part, which is 102. Let me bring the A matrix again. There are times that we are interested to find the numbers, the number of elements inside a matrix. So I want to know how many elements are inside this matrix A. We learned that the size what it does, it returns the dimension of the matrix. And if we multiply the dimension, we can find the elements inside it. But you know what I need is to find the elements through only one function. There is actually a built-in function inside Matlab called normal. So if I say normal and open parentheses, pass matrix A, what it does, it simply calculates the number of the elements inside matrix A with just one function. So what we learned today, let me recap that, is that if we do have matrix A here, if we want to find the minimum, we just pass it twice. If we want to find the maximum, we pass it twice. And if we want to find the whole number of elements inside matrix A, we pass it by normal. And Matlab just finds the number of the elements. Thank you very much and keep practicing. I see you in next video. Hello everyone, welcome to Matlab Programming course. I'm Hossein Tutunchi, and today we're going to explore the matrices in more detail. One of the areas that we need to learn in matrix algebra is to create bigger matrices by combining smaller ones. So the way to do that, let me create a matrix. Let's do it 3 by 3 for now. Okay, so I created a matrix which is 3 by 3, and then let me create another one which is 2 by 2. If I want to combine these two matrices to build a bigger one, what I can do is to put A and B. And if I do that, you see Matlab gives me an error which represents the inconsistency of the dimensions in matrices. And actually Matlab is not going to expand this B matrix with additional zeros just to augment it into a 2 by 3 matrix, so we can expand this and augment it with A. Therefore, please pay attention that in order to be able to combine matrices together, we're required to check the dimensions first. The way that we can do, if we create another elements here, now we do have a 2 by 3 matrix, and I now easily can combine these two matrices like that. Therefore, while performing matrix calculation and matrix creation, always be mindful of the dimensions because they can easily create errors. Hello everyone, welcome back to Matlab Programming course. Today we're going to learn more about the functions and their effect on matrices. Let's start by creating matrix. We do have matrix A. Yes, okay. So we have created matrix A here, and what I want to do is to find sine of A. And if you do that, you will notice again sine, as we learned earlier, whatever comes inside the parentheses is going to be in radians. So Matlab always performs in radians. This is 1 radian, 4 radian, and stuff like that. Therefore, Matlab calculates it easily. We can do another hyperbolic function and get the same result. We can come up with matrix B, so it's B. B is like that. So let's do cosine of B, see what happens. You see that Matlab has no problem calculating that. Another function that we frequently encounter in matrices is square root. So as we learned, we can calculate this square root of a, and let me bring a here as well. So square root of 1 is 1, square root of 4 is 2, and square root of 6 is 2.4, and so on and so forth. However, in MATLAB there is another function, square root, which is specifically designed for matrices. In order to do that, you can type duck sqrtm. So instead of sqrt, now we do have a sqrtm, and if we do that, it's a matrix. M stands for matrices. So if I do that, you can see that there is a definition. Sqrt of A is the principal square root of a matrix. X by X equals A. So I wanted to know what are two other matrices that if I multiply them together, I can find the matrix A. So let's try that. If I say sqrtm of A, I get matrix which is complex now, and let me name a value for it. I name it R, sqrt of A, sqrt of M. Now I do have matrix A, which is the square root of A. Now what happens if I multiply R with itself? You know, it's a square root of matrix A. Therefore, if I multiply it once more with itself, it should create the original matrix A, and it does. If you look closely, you see that they're imaginary numbers, but they're all 0, right? So we came up with the same original matrix A. If I type matrix A here once more, you can see that now they're identical. As we learn, 2 multiplied by 2 equals 4, and this one, the same, is true with sqrtm of A. So how MATLAB interprets this function is that what are those two separate matrices that if we multiply them together, it's going to create matrix A. And this is the result. Let's do it with B as well. So what is B? Sqrtm of B. And you see that there is an error which indicates we're only able to perform such action on square matrices. So if you ever wanted to use the sqrtm of A or any other matrix, please make sure that your matrix is a square one, else there's going to be an error. This is not as common as sqrt of the matrix, but there are special applications where we need to do that. Those studying in control engineering field frequently use this function. Let me clear the screen. So I do have matrix A, and we do have the same concept with exponentiation. So if I put exp of matrix A, and MATLAB just easily calculates the result. However, there is another function in MATLAB which is specifically designed for dealing with matrices when going to and the function is exp of matrix A. Now if I do that, you see that a new result will appear. And just to give you a short introduction with this one, this is also known as phi matrix, and it is very fundamental in probability, in control engineering, and we can easily find the response of a system, including the transient and the steady state responses, by calculating only this function. So it is really important. It has a special use, but there are times you need to use the exponential function for matrices. The same is also true with logarithmic functions. So if I put logarithmic a, it just goes and calculates the logarithm of each element. Let me clear a screen and put a here, and then log of a is going to be calculated one by one correspondingly and put it here. But there is also another function called log m of a, and if we calculate that, there's a warning, just ignore that, but you see that a new entity is just created, which is totally different from what we got here. And I wanted to emphasize that the whole story here is that if you're dealing with matrices, so there are special functions for them designed in Matlab, and be aware that if you calculate the normal functions, they're going to produce different results than those functions specifically designed for dealing matrices. It is a very important point to remember. Let me clear a screen for the last item here. What if we wanted to raise the matrix, raise a number to a matrix, like 2 to power a? We do have a matrix, we do have a number, and we want to raise it to a matrix. So if we do that, Matlab easily calculates the result. These functions have special usage, and be sure that you're mindful of that. Be sure that you know where to use them. For example, if you wanted to do it element by element, which is more frequently used, we can put it like that, as we learned with dot. It indicates that each element inside A is going to be raised. Please note that we do have a different notation when we raise the matrix to a power, like this one. So let me clear the screen. This is A, and what if I wanted to raise the matrix to power 2? So if I do that, you see that a new result, which is also a matrix, is created. But the answer is not really relevant. It doesn't make sense that 1 to power 2 is going to be 27. Again, remember that we do have element by element multiplication, division, subtraction, and power. So if I do that, now you see that 1 to power 1, 1 to power 2 is 1, 4 to power 2 is 16, 6 to power 2 is 36, and so on and so forth. The beauty is that whatever we learned so far is applicable to newer functions, to newer matrices, algebraic functions, and whatever we learn, it is just interconnected together. We need to practice using them together so we feel confident while we're dealing with programming. Thank you very much for watching this, and I'll see you in next video. Hello everyone, my name is Hossein Tutunchi and welcome to Matlab Programming course. Today we're going to learn more about a special set of matrices in Matlab known as special matrices. And they're called special because they do have specific use in engineering. The first one, which is frequently used, is zeros. So the way to create matrix zeros, and you can guess what it does, it asks for a number. Let me put 2. And if I do that, it creates a 2 by 2 matrix, which all of its elements are 0. And we can easily create 5 by 5, or even bigger. And one of the use of these, when you wanted to create a big matrix and there are only certain elements of this matrix is going to be filled, it's better to create a zeros like this one. Let me create one like that, 7 by 7. And then let me actually put a name for it. Let me put it A zeros 7. And now if I come to here and double click on it, I do have the values here. For example, I wanted to create a new value for it. How about here? 1, 43, -6. So by doing that, if I call the matrix A, now it is the revised value just appears, and you can tell that by doing so you can create the desired matrix much faster. Let me clear the screen. Another important function that we use a lot is ones. So ones, and again it requires for a number, so we put 2. Unlike the zeros, which only creates the 0 values, it will create ones. So I put ones 5, and so a matrix will be created. You might be asking that, is it always going to be the square matrices? And the answer is no. You can create zeros of 3 and 4, which is perfectly fine, or ones of 2 and 5, which is again 5. Let me clear the screen. Another special matrix that we need to know is a diagonal matrix. One specific matrix is very well known in engineering field, and it is called the identity matrix. The way that we create identity matrix in Matlab is through a function called I. If I put I and Matlab asks for a number, I can put 4, and look what happens. If I do that, a matrix will be created, which first of all is a square matrix, and second of all the diagonal elements are 1 and all the other ones are 0. This is the definition of the identity matrix. Similar to ones and zeros, I matrix can also be different than a square matrix, like this one. So if I do that, you see that Matlab tries to create the I matrix as long as possible, because this is the definition of the matrix A, but because it's not a square matrix, Matlab is not able to create it, to make it a square. We can also put it like that, and you see that Matlab just tries to create a matrix as close as possible to identity. Let me clear the screen. One specific characteristic of the identity matrix is that when it's multiplied to any matrix, the result is going to be that matrix, the original one. Let me show how does it work. So if I have, let's see what's A, it's a big one, let's go with B. Okay, so we do have a matrix B, and if I multiply it by I, so B multiplied by I of 4, you see that the dimensions does not agree. And it's very important to note that even special functions like I should match in dimension. So what is the dimension of B? The dimension of B is 2 by 3. So if we can create an identity matrix which is 3 by any number, we're able to do the multiplication. So let's create one. I have 3 and let's go 5. How about that? So it creates this matrix, and now if I multiply B multiplied by I, 3 and 5, you see that now the multiplication is possible. But the dimension of the result is not the dimension of the B, because the B matrix is this one. But now we do have 2 additional columns. The reason being is that we're only able to claim that the result is going to be the original matrix when the identity matrix is a square. So let me clear that. If I do have a matrix called B, which is a 3 by 3 matrix, like that, and I create an identity matrix called let's make it 3 by 3, like that, and if I multiply B to I, multiply them together, you see that the result is going to be matrix B. The original matrix is always true. So if you multiply any matrix with identity matrix, which is squared one, the result is going to be always the original matrix. Let me clear the screen. Another matrix that I would like to introduce to you is the magic matrix. So the magic, it just receives one number, and I put 3 here. So if I do that, magic 3, and I hit enter, you see that a new matrix is created, which is 3 by 3. And what is the magic number? Let's ask Matlab. So if you search that, the magic returns an n by n matrix constructed from the integers 1 through n squared with equal row and column sums. Equal row and column sums. So what is the magic is that if you add the row elements and the column elements of this matrix, the result is going to be the same. Let's try that. What is the sum of the first row? Therefore, if we add 8 plus 1 plus 6, the result is going to be 15. Let's try this one. 8 plus 3, 11 plus 4, it is 15. How about the second one? So 1 plus 5 plus 9 is 15. And this one, 4 plus 9 plus 2 is also 15. Therefore, the summation of all elements in this matrix, therefore the summation of the rows and columns of this matrix for any specific rows and any specific column in this matrix is going to be a same number. It's called the magic number. There are also other special matrices which are not frequently used, so I leave them to you. So if you like, you can search the Matlab for special matrices, and there are a couple more that you can explore. Hello everyone, welcome back to Matlab Programming course. Today I'm going to show you how we can calculate the transpose of a matrix, which is very important. There are a lot of areas where we need to find a transpose of a matrix in order to get the result. So let me show you how we can do that in Matlab. Exactly like vectors, when we had a vector, let me create one. Here we do have a 1 by 5 vector, and I showed to you that if you wanted to calculate the transpose of a vector, the only thing we need to do is to put a single quotation exactly after the name of the vector. And if we do that, we can come up with a 1 by 5 vector. The same holds true with matrices. So let me clear the screen. I put A equals 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, and 12. So now I do have a 3 by 4 matrix, right? So if I calculate the size of A, it's going to be 3 by 4. Now, if I want to create the inverse, what I need to do is put, let me call it B also. So what I need to do is to put A transpose, right? I put B, a new matrix, which is the transpose of A. And if I do that, you see that we create a 4 by 3 matrix. So size of B is now 4 by 3. Therefore, exactly like vectors, the way to calculate the transpose of a matrix is through employing single quotation. Let me clear that. Another important feature we need to learn is, let me create a square matrix. I'm just trying to create a, let me make it different. So, okay, I think it's okay. Now I created a square matrix which is 4 by 4. Sometimes we need to extract the diagonal elements of a matrix like this: 1, 6, 5, and 2. So I'm only interested on the diagonal elements. The way that I can do that is through a function called diagonal. So diagonal of matrix A simply calculates only the elements on the diagonal. So we could easily extract that. And if you need it in a 1/4 vector, what you can do is to put ends like that and calculate it. It's always better when you extract a part of a matrix, you make a name for it. So for example, it would be better if I put D equals diagonal of A. So now I can put D transpose. So it's easy to calculate the diagonal elements, and they're very important, especially in some areas like control engineering, because it enables us to calculate the eigenvectors, eigenvalues, and other important features. Okay, so let me clear that to start the next item. There are a lot of times when we need to just extract a portion of a matrix. Let me bring A here. Okay. So what if I need only the upper part? So if you look at it, it's a square, and I can divide it imaginarily by just drawing a line on the diagonal to make it upper and a lower division, right? So if I draw a line on the diagonal elements, they're going to be divided into upper and lower. What if I was interested into extracting the upper part of a matrix? How can I do that? If I cut the upper part or the down part of this matrix into half, it's going to be a triangle. So I can use a function triangle, and now I need to specify whether it's upper part or the below part which I'm interested. Now let's go to upper part. And if I do that and pass A to it, you see that the new matrix which is created is all the elements below the diagonal element the diagonal line is going to be 0, and the upper part is only left. So it's like that. We only extract the upper part of this matrix and put everything else into 0. We do have a very similar option on lower elements of the diagonal. So let me do this. We can extract the lower part by try low and pass the matrix. So if I do that, now you see all the upper parts are assigned to 0 and the lower part is left. If I want to give you an example where we use these, we all had numerical analysis courses where you were asked to find the values for 3 variables numerically. And later in project section, I'm going to use all these features and show you how useful they are in programming field. So today we'll learn how to extract the diagonal elements, the triangular upper part, the triangular lower part of a matrix, and also the important function of transpose. Please keep in mind that you need to practice all these functions in order to instill the Matlab programming skill. So far, you've done a great job, and I will see you in next video. Hello everyone, welcome back to Matlab Programming course. This is Hossein Tutunchi, and today I'm going to show you how useful Matlab programming is in calculating time-consuming problems and calculations. We all had a numerical analysis and just algebra courses that we were required to find the solution of system of equations. And you know, it's not hard, but it's time-consuming, and it's not the best of the feelings. So let me tell you what's the story. Let me create a matrix. Let's call it A equals 1, 4, -3. And the other one is 6, 2, and 8. Okay, so I created a matrix like that. What I actually mean is this one. So the whole system of equation was like x plus 4y equals -3. Okay, so the first line I represented this way, and the second one was 6x plus 2y equals 8. So you were asked to solve the system of equation like that, and we can represent the system of equation in matrix format, which is called the augmented form, because the first 2 by 2 section of the matrix represents the variables and the coefficients of the variables, and the last two parts represent the values. So let me write the matrix A here again. Sometimes you were asked to find the values for x and y, so the equations are satisfied. There are different solutions for gaining the result, but today I'm going to show you one of the easiest ones, which is called the reduced row echelon form. And if you want to further investigate that, you can type doc RREF. RREF, and if you hit enter, you see that RREF, you can read the definition and what it does, but I'm not going through that just to complicate things. I'm not going through that because it just is going to make things more complicated here on the definition, but what I'm gonna do is to show you how useful the whole thing will be. So with that, I can type RREF and pass the matrix that we were working on into that function. And look what happens. If I do that, you see that the Matlab just solves the equation for you. There is a 2 by 2 matrix here. If you imagine like a line separating these two, so the 2 by 2 is a diagonal matrix with 1 on the diagonal parts and some results. And the way that you can read it is x equals to 1.727 and y equals -1.1818. How easy it was. Just by typing one function, we were able to solve the equations. Let me show it to you by doing a 3 by 3 matrix. So I clear that and I put B equals 1, 3, -2, 5, 6. It should be 4 by 4. So 5, 6, 4. Excuse me, it should be 3 by 4. So this one and 1, -12, 8, and 2. That's it. So now I created a matrix, and the way that you can read it is 1x, 3y, minus 2z equals so on and so forth. Now I want to find the values of x, y, and z that makes the whole set of equations satisfied. The way that I can do it is R, R, E, F of matrix B. So if I do that, Matlab easily calculates the result. Now you can find that z value is -2 and y value is this and x value is this. It's really fast and super easy to calculate the results using Matlab. Thank you very much, and I'll see you in the next video. Hello everyone, welcome back to Matlab Programming course. So far we learned a lot about matrices and vectors, and the reason that we're working on these topics is that the programming is dealing with all these features and how you can manipulate the functions in Matlab to get the results, and there are always different ways to do that. So it is necessary for us to expand our knowledge in Matlab. So in case that we are presented by a different sort of problem, we have some idea how we can approach that and actually solve it. Today I'm going to introduce you more of the matrix functions, which are really important. Let me clear the screen, the variables. I'm going to define a new matrix. So I define a new matrix. I'm sorry, I put okay, so I define a 3 by 3 matrix, and now I'm going to calculate the trace. In this video, I'm not going to explain about the mathematical aspects of the things because this is not the purpose of this course. However, I'm going to show you how you can calculate different results which are related to matrices with Matlab. So the trace, if I do that, it's 6. And what is the trace? Is the summation of all the diagonal elements in a matrix. We do have 1 plus 5. The result is 6, and it is the diagonal summation known as trace. The next one is rank. So rank of A, it's also very important. You can pass it through the function called rank, and if you hit enter, you see that the rank of the matrix is 3. It's especially useful when the matrix is not diagonal. So let me come to the first line and define a new function. 1, 2, 3, 4, 5, negative 1, 3, 9, and 3, 1, 9, 8. Okay, now I created a 3 by 4 matrix, and as you see, it's not diagonal. Let me calculate the rank of B, and you see that the rank is 3. If you're interested to further explore the meaning of the rank in matrices, you can also visit the Matlab documentation, which explains every function in more detail. Let me clear the screen. Another important value we need when we're dealing with matrices is the determinant. And the way to calculate determinant is to pass the matrix into det function, which stands for determinant. And now, because we need a square matrix, you cannot calculate the determinant for those matrices which are not square. So I do happen to have a square matrix I define here, A. Let me type determinant of A. And if I do that, you see the determinant is going to be negative 24. If you have tried to calculate the determinant of a 2 by 2 matrix, it's going to be, easy and almost fast. But when it comes to a 3 by 3 matrix, it's going to be really time consuming. However, there are tools like Matlab that makes this task super easy for you. To show you that the math determinant is only calculated with square matrices, let me calculate the determinant, the B, which is not a square matrix. If I calculate, you see that the error defines matrix should be squared. Let me clear the screen. The next important thing I wanted to show you here is inverse. So I do have matrix A, and I wanted to calculate the inverse. The way that we do that is through using INV function. INV of A just calculates the inverse of A. That's simple. How about B? If you do that, you realize we're not able to calculate the inverse for a matrix which is not squared. In this video, we'll learn how to do the rank, how to do inverse, and also the trace. I hope you enjoyed the course, and I see you in the next video. Hello everyone, welcome back to Matlab Programming course. I'm Hossein Tutunchi, and this is going to be the last video of matrix chapter. In this chapter, we learned a lot about matrices, and we used very useful and actually the most important functions in matrix manipulation. And I am going to end the chapter with a very important topic on symbolic matrix calculations. The reason being is there are a lot of times that we are not working with numbers. We're dealing with symbolic calculations. We're dealing with variables. And therefore, we need to know how to work with Matlab and solve the matrices symbolically. Fortunately, Matlab is equipped with Symbolic Toolbox, and we're going to cover the matrix calculation symbolically today. So let me define our variables, sims x, a, and b. These are the variables that I'm going to work. Let's define a 2 minus x. I'm creating a 2 by 2 matrix, by the way, 3x cubed. And for the second row, let's go with 4x squared minus 3x and 9x squared plus 9x squared and plus 2. So this is going to be matrix A. And if you look closely, you see that Matlab shows the symbolic matrices differently than what we learned. And also commas are used in order to separate elements. So let me calculate B. 2x minus x cubed 8x plus 1, and the second row is going to be x minus x cubed and 5x plus 8x cubed as well. Okay, so I created two matrices which are 2 by 2, and as you see, there are no numbers in there. They're all symbolic, and I'm going to show you that it's really easy for me to calculate, for example, the inverse of A. Matlab has no problem to calculate the results symbolically, and also we can pass the pretty ants, and Matlab just can show it very beautifully. Also, we're able to calculate the multiplication and pretty ants. Just the multiplication is shown, and all the parts that we learn throughout the course, we can just subtract them. We can make the summation like that. And as you see, we could get the results very easily. And let me clear the screen. We're able also to perform element by element calculation, and Matlab is able to create the results very intuitively. We're also fully able to investigate all the parts and all the functions we learn, like transpose, inverse of x, inverse of a, and just finding the trace of b. We're fully able to do that. And like the determinant, one of the most important ones, we can do that also for b. And as you see, we are really comfortable with any sort of calculation in Matlab if we know how to deal with it, how to approach it using the right tools and functions that we learned. I hope you've learned a lot throughout this course, and don't forget to practice, because that's what really matters and will make you a proficient Matlab programmer at the end. As we progress throughout the course, we get closer and closer to programming parts where we need to use all the things we learned here to make functional programs. Thank you very much, and see you in next chapter. Hello everyone, welcome to Matlab Programming course. I'm Hossein Tutunchi, and today we're going to start a new chapter on defining functions. We want to learn how to define functions in Matlab, and this video is going to be one of the most important ones in this series because from this day on we always use this function in our programming, and it is one of those fundamental functions in Matlab programming. Okay, so let's get started. You know, when we define x equals to 3 and then we type sine of x, Matlab already knows what sine means. So when we pass an argument into that, it already has the algorithm, it just calculates it. The same with the sqrt. When we do it, -5 for example, so Matlab returns a result or absolute value of -12. Matlab already knows how to behave when an argument is passed to it. But today we're going to tell Matlab to consider customized functions. The way that we do that is through a function called inline. So what we can do is to name it like function, or let's do my name, Hossein, equals. You can put any variable or name instead of my name here. I encourage you to put yours. So this function is going to be inline. So when you put inline, open parentheses, Matlab asks to insert the information we want to put. So the first thing is going to be, what's going to be the expression? What do you want me to do when you pass the arguments to me? So let's do something. We put single quotation, and let's our function to calculate absolute value of x. We close a single quotation, and then we need to tell Matlab what is the independent variable. The independent variable is x. So it is something that we pass to Matlab to calculate. So what it does is whatever value we insert into inline as x, Matlab is going to return the absolute value of that. And what is the name of the function? Is Hossein, my name. So let's do that. If I hit enter, now Hossein is defined as inline function. Hossein of x equals abs of x. So let's try that. If I say Hossein of 3, then the result is 3 because absolute value of 3 is 3. How about Hossein of -4? We expect the answer to be 4 because what it does, it returns the absolute value of the input. The answer will be 4. Let's create another one. Let's go with new. I call it new equals inline. What is the function that we're gonna define? Let's do something like exponential of x, absolute value of x plus sqrt of x squared. That's enough. So this is going to be the function, and what is the independent variable here? It's going to be x. Okay, so now I defined a new function called new of x. Let's pass variables here. New of x of 1. This is going to be the answer. How about new of 0? Very good. How about -2? You see, by defining function, it's really easy for us to calculate different values very fast. Instead of just writing the whole function over and over again, we can define it as a new variable and just pass it to the function. And also, when you want to get rid of the function like new, all we need to do, as you see here, it's now recorded as a function into Workspace. All we need to do is to call clear and the name. If I do that, it removes. Look at the Hossein here. I just want to remove myself. Doesn't make sense, but anyway. So clear Hossein, and it's all gone. And if I type Hossein of 3, Matlab just doesn't know what I'm talking about. So let's clear. So far, we've learned how to deal with functions with only one independent variable. But how about if we have 2 or more? In this section, I'm going to show you how we can calculate those as well. Okay, so let's create another one called parabolic. And what it does, I'm going to define two independent variables, x and y. And when I pass this, the function is going to calculate the sine of the first variable plus the cosine of the second variable and add them together. So let's do that. We type inline, and it asks what kind of information we need to do. So we put two single quotation and comes between. We put two single quotations, and in between we write sine of x plus cosine of y, comma, and what are the arguments? X is one of them and y is the second. And if we do that, we define the parabolic function. So let's go with parabolic of 1 and 0. The answer is going to be that. How about parabolic of 2 and 6? The answer is going to be that. And I think you get my point that we can define a lot of functions with different variables, and the only thing we need to do is to pass the input to that function. It's going to calculate the output very easily and conveniently. Hello everyone, welcome to Matlab Programming course. I'm Hossein Totunchi, and today we're going to continue with differentiation. In this video, I'm going to use the inline function to create a new function and then take derivative of that. So let's call it, first we put sims of x, and then we call it f equals inline of, let's go with sine of x plus 2 times cosine of x, and then what are the variables is going to be x. We learned that. And the new function is called f of x equals sine of x plus 2 cosine of x. Now let's try to take the differentiation of what's the function? It's going to be f of x and x. We learned that we can take the derivative of f of x like that, the first derivation, and the Matlab is going to calculate that easily. And let me show you something very, very important. Let me redo the calculation, the last calculation again. So I'm going to make a name for it. Let's say I call it like f1. I call it function 1 equals. So it is exactly the same thing, but I just made a name for it. So then I hit enter, and now f1 function is like that. Now let's try to pass a value to it. So I'm going to know what's the value of f1 of 4. Okay, so if I do that, you see that you receive an error. And you might be thinking, what happened? I take the derivative like that, and the derivative works, but why I can't do it? Please keep in mind that the only way we can pass a parameter into a function and calculates it is that Matlab must know that function, must recognize that function, and not just an expression. Because right now f1 is just an expression. It's not a living thing. There is no functionality to f. It's just an expression that the value you're searching for is cosine of x minus 2 sine of x, but we're not able to evaluate the expression. Therefore, the solution will be defining the new differentiation result into an inline function as well. So let me clear the screen and show it to you how we're going to do that. As we remember, we defined the function f like that, and we're going to calculate the derivative and make a name for it so we can pass parameters and calculate the results. I call it derivative equals inline. Inline was the way that we could define a new function which is able to receive parameters. So this way I call it differentiation of f of x and x, and then what is the variable? It's going to be x. So I define a new function called the derivative. And if you pay close attention, I didn't put this part into single quotation. The reason was that we put this part into single quotation when we are defining a new function. But the result of this expression, this internal expression itself is a function. So there is no point to define a function when it is already a function. I hope that I could make sense in that. So then we calculate the derivative of x, which is cosine of x minus sine of x. Now we're able to pass values to it and get the result like that. -1. And you can do whatever you like. You can just pass the parameters and it's going to calculate the result. So in order to do a fast recap, in this video, we learn how to take the derivative, how we define the new function, and if we need to calculate the value of the derivative at some specific point, then we need to convert the derivation into a real function and not just expression. That was really the important thing in this video. Thank you and see you in the next video. Hello everyone, welcome to Matlab Programming course. In this video, we're going to learn how to do differentiation, and it's one of the most important functions in engineering, and there are a lot of applications where we're required to calculate the differentiation and find the value at specific points. So it's necessary for us to learn how to deal with such problems. The way that we need to calculate the differentiation is a little different than other functions because differentiation and integration by nature are done symbolically, and it is different than like sine of x that we just pass a value, a parameter to the function and calculate the result. In order to do that, we define a function sims of x, and let's create a function. I call it func equals, let's just start with something easy. Let's go with x cubed. If I do x cubed and the function is created, in order to calculate the differentiation, what I need to do is to put diff, this is the definition of differentiation, and open parentheses, the name of the function, which is going to be func, and what's the independent variable, x. Please note that we didn't use any single quotation or stuff like that. We just passed the function and the variable into the diff or differentiation function. Let's calculate that. As you see, the Matlab calculates the differentiation easily. Let's calculate something more difficult. CLC, and we also had our sims of x. Let's calculate the g equals to sine of x divided by x squared plus 3 of cosine of x, and let's close the parentheses just to show it like clearly. This is going to be the g function. Now let's calculate the differentiation of g, and what's the independent variable? X. And if we do that, Matlab calculates the result. Let's put it pretty of answer. It's going to be like that. So you see that Matlab easily calculates the results, the differentiation, and it can be anything, even much more complicated examples. I encourage you to just create functions and pass it to the Matlab and test the result. It's going to be very, very important, and you will have a lot of functions like that. Hello everyone, welcome back to Matlab Programming class. Today we're going to learn how to do integration, both indefinite and definite integrations, and it's going to be very useful because there are tons of applications out there that we require to find the derivation, the integration, and do particular calculus-based operations in our problem in order to solve it. And today we're going to learn one of the most important ones, which is integration. Let's get started. The way that we define integration in Matlab is through a function called int. Before that, let me create a function, call it f1 equals. Let me put it in line exponential of, let's just start with something easy. Let's go with x. I define a function called x, and what's the variable? Also x. I can easily pass values to that, like 3, and there is going to be 3 because it's a linear function. The integral function equals int of, and we define it like that, f1 of x. This is our function, f1 of x. And now we need to tell Matlab what is the d of x, the second part, because each integral has a function and a d of x part, which indicates what is the value of concern in that particular integration. So we can do it by passing x to it. If you do that, you see an error. The reason is not that we did it wrong or misspelled something. The reason is Matlab does not understand what x is going to be. And it is expected, because if you look at the workspace area, you see that there is no x. We do have a function, and that function has x in it. It is totally fine when we come to calculating the value of that function for a particular x. However, if you wanted to perform some symbolic calculations, we need to tell Matlab that we're dealing with a symbol. So let's do that. I define sims of x, and if I hit enter, you see that the x now is created. So let's do the calculations again. I come here, and if I hit enter, Matlab calculates the integral, and I can easily pass the function, and you will see that the famous x squared over 2 is simply calculated. Now we learn how to calculate any function and the integration of any function in Matlab. Let's go and calculate some more. So I put home. I call it f2 in line of, let's go with something parabolic. Sine of x plus 2 cosine of x. And what's the variable? It's going to be x. Now I define a new function called f2, and it is symbolic because x is defined as a symbol. Now I can calculate the integral equals int of f2, and what's going to be the x? The d of x is going to be x. So if I calculate that, you see that Matlab has no problem deriving the function. At this point, I wanted to show you something, and I'm going to bring the last calculation I've done. This was the last part. In our function, in our defined function here, the only variable we're dealing with is x. There is no y, there is no t, there is no z. There is no other variable in that function except x. Therefore, Matlab already knows that the only variable we're dealing with is x variable. Here, we can simply get rid of x because there is no other option. If there were like other variables, x and y, then we had to define which variable we're talking about. But here, we're solely interested into x, and Matlab is smart enough to understand that part. So if I hit enter, Matlab has no problem calculating the function for us. So with that said, let me bring a new screen. And using home has the ability that if you wanted to see the calculation before, you can just scroll up and see what were the last calculations. In this part, I'm going to create a new function, and this time I'm going to put more than one variable here. And let's go with x multiply y plus sine of x. I'm going to calculate something big. Let's go with x plus y minus tangent of y plus 3 exponential of x cubed. So as you see, this is really a hard integration, and also it has more than one variable. It has x and y. So let me define our variables as well. This is going to be the function. Again, there is no y here, so if we go and calculate the value for integration, we receive an error. So let's go with sims of y. Now we tell Matlab that there are more than one variable involved. So let's go with an integral function equals int of f3 x and y. And now, because we do have more than one variable, we need to tell Matlab which variable is important for us. Is it x variable that we wanted to take integration according to, or is it the y variable? So this time, let's go with x. I tell Matlab that I know the function has x and y, but I want to take integration for x variable. If I do that, pretty of integral, and you see that Matlab very easily calculates a very hard integration for us. Now let me bring the last calculation. This time I put y, and Matlab calculates it as well. Pretty integral. It will calculate it. So you see how productive Matlab can be in very complex calculations. And when we learn how to work with Matlab, it's going to be really fun experimenting with different complex functions, testing your theories, and honing your skills. Up to this point, we've learned how to do indefinite integration. Now we need to know how to do the definite integration. As a matter of fact, it's very easy to do that. Let me clear the screen. I can go and bring f1 function that we created. It was the linear one. And integral equals int of f1 of x. And now I wanted to tell Matlab go and calculate the definite integration. As you know, the definite integration has two limits, the lower and the upper limit. And now I can easily tell Matlab that I wanted to calculate from 0 to 1. And Matlab has no problem calculating for us. Or I can do it like minus 12 up to 5.8. And you see that Matlab has no problem calculating. Let me bring the f2 function here. F2. So this was the function that we worked with, and integral equals int of f2 of x. What are going to be the limits? It's going to, let's go with -4 to 19. So the lower limit, we do have only one variable. The lower limit is -4 and the upper limit is 19. The Matlab calculates it. As we learned before, the results are in radians. These are not the degrees. And if we need to know the real value, the result in decimal format, we can go double ans, and it will bring the result to 3. Finally, let me bring the last function with it, which has two variables. And if we go with integral f3 of x and y, and now the integral is going to be int of f3 of x and y, and then what's going to be the variable is going to be x. And if I do that, I can find the calculation as before. I can bring it up and go with -1 up to 4. Let me make it more clear. Pretty integral. So if I do that, it's going to be a big one, but you can notice that Matlab understands this is the range for x, because the y variables are still in there, but there is no x, simply because the x variable were substituted by these margins. And one time it's calculated as the lower limit with -1, the other one with upper limit. Hello everyone, in this video we're going to cover the limit, one of the most important functions in calculus and engineering that enables us to get the final result of a function when we're dealing with this special trend. So let's go and learn how to deal with limit function. In order to find the limit, there is a function in Matlab called actually limit. Let me call f1. I'm going to create a function in line Let's go with one of the most famous ones. It's going to be sine of x over x. Forgot the single quotation. You go like that, and then x is going to be a variable. We created actually a fun function, which is f of x. And if you remember, this is not a symbolic, this is an expression. And as you might have guessed, exactly like derivation and integration, if we go past this function to limit and we want to find the result, Matlab is going to give us an error because it doesn't understand what this f of x is. Therefore, it's necessary for us to create symbolic variable x first. Now, if we repeat the same thing, now this is different. The way that we calculate the limit in Matlab is through the limit function. And how we do it is first, as you see the suggestion bar comes in, first is expression, then the variable, and last the value we're approaching. So what's the function here? f1 of x. What's the variable? Of course, x. And what's the value of x will be when we approach that? Let's go with 0. And the way that we read it is, what's the limit of f of x when x goes to 0? And it's one of the famous limits, and if you remember, the result will be 1, like that. Therefore, this is the format that we calculate the limit. Let me create another one. I want to introduce a new variable as well, so I go, let me clear the screen. I go with sims of x and y, and now I go with f2 function will be in line of sine of x plus 1 plus y minus sine of x over y. And what are the variables is going to be x and y. So this is the function f2 inline function that we created, and it has 2 variables. Now we're going to find the limit. So limit of f2 of x and y. And what is the variable we're interested? It's going to be x when it approaches to 0. Let's see what's the result. I made a mistake. Oh, so f2 function here, I should put it this way. Sorry about that. So if I calculate f2, now I come to value of f2, and if I calculate, it just brings the result as sine of y. I forgot the left parenthesis, sorry about that. But as you see, when we type everything correctly into Matlab, it is going to be easy to calculate the limit. So let's calculate something fractional. Let's go with h equals in line of, let me calculate it as 4 times x cubed minus x squared plus 2x and minus 1. This is going to be numerator, and the denominator is going to be, let's go with 3x cubed minus 7x squared minus 1 minus 9. Let's go with that. And then what's going to be the variable x? So I calculated the h, and now h of x is symbolic because we have defined the x. Let me see if I can type the h more pretty. Yeah, that's better, much better. Now I want to calculate the limit. So I go with limit h of x when x goes to, let's go with 0. So if I calculate that, the value is going to be 1 over 9. How about when it goes to infinity? I type INF as the infinity. So if I do that and calculate it, Matlab has no problem just finding the biggest coefficients of the numerator divided by biggest coefficient of the denominator is going to be 4 over 3. As the last example here, let me show you that how we can combine the vectors with limit function in Matlab. So As we learn, vector serves us as entities that has bigger dimensions. So we can calculate multiple values and variables at the same time. To show you an example, let me create symbols x and a, and then instead of defining a function, I'm going to create a vector which has functions. So the first element is going to be 1 by 2, so 1 plus a over x, and let's raise that to power x, something very difficult to calculate by hand. So for the next part, I go with exponential negative x. This is our new vector. Now I want to, and you know that it has 2 elements in it. Now let's go with limit. Limit of v, this is the vector, and what's the variable? X, when x goes to infinity. So now I'm not dealing with a function, I'm dealing with a vector. And let's see what happens. When I calculate it, the result for the first part is here, and the result for the second part is here. So you see that you can give Matlab a range of functions and then ask for the limit, and Matlab has no problem calculating all the values and return the results in the form of vector. Hello everyone, welcome back to Matlab Programming Class. I'm Hossein Tutunchi, and today we're going to continue our discussion on derivatives. One of the most important areas in calculus is partial derivatives. And as you know, there are numerous applications where we're required to find the value of a function at some specific points and then continue from that point on. As you know from calculus, partial derivatives make sense when we're dealing with more than one variable. We can define variables like sims, x, and y. And then now I'm going to create a function called f1 equals. As before, I use inline. And let's create x, something easy to work. X squared plus 2, let's go y cubed, just to start. And then what are the variables are x and y. We can create a function which has more than one variable. Now we're dealing with x and y. As we learned before, we can calculate the derivative as passing diff. And what's the function is going to be? It's going to be f1 of x and y. Because now we're dealing with more than one variable. Without it, you get an error. At this moment, we're required to tell Matlab which variable we're interested in, so Matlab can take derivative according to that particular variable. As we know in partial derivatives, we're interested in one variable at a time. At this moment, let's go with x. I'm telling Matlab to calculate the partial derivative of a function which has more than one variable, x and y, and now I'm particularly interested into x variable only. If I calculate this, Matlab has no problem to take the derivative of the function, which was a complex one. The way that the Matlab approached this problem was that because we told Matlab that we're interested in x, therefore this part of the function which has y is going to be considered as a constant, and the derivative of a constant is going to be 0. Now let me try that again with a new function called d2, derivative of function f1, the second derivative, and here instead of x, I tell Matlab to calculate it for the y variable. And if I do that, you see that Matlab this time considered the first part of the function as a constant and took derivative of this part. Let's calculate another one. Let me clear the screen. With x and y already defined as symbolic variables, now let me create the second function as inline of x sine of y. I'm trying to calculate something more complex than before. Minus y multiplied by sqrt of x, 4. And what are the variables are x and y. So in this part, I defined a much more complex function, and then the x and y still are our variables. With that said, the f2 function was created. Now I am trying to calculate the derivative. I define d1 equal diff. What's the function? f2 of x and y. And at this point, I'm interested in x variable only. Matlab has no problem deriving the complex operation for us. Now I pass the d1 function into Matlab, and it has no problem making that more clear for me. At this point, let's go and calculate the function again. This time I changed the name to d2, and let's calculate it according to y. And if I do that, now let me make that more clear. And as you see, if you want to do it on paper, it's going to be very hard and time consuming. Let me clear the screen. As we discussed before, we have no problem calculating the function. This is the last one, the derivative that we found. But there is a problem. If you're interested to find the value of this function in some specific points, because now we do have a function called d2 and it has x and y. But if you want to find the value of this derivative at some specific x and y, we're not able to do that. So if I do this, d2 of, let's say, x and y, not x and y, 1 and 4, let's say, because I wanted to substitute the values. If I do that, Matlab does not understand what we're doing, because the d2 function is not defined for Matlab as a function. It is defined as an expression. So this one is merely an expression. And as we learned before, the way that we can do that is through a new function, which we can easily set up through inline. So I put inline diff of f2 x and y. I'm just setting up the whole thing again. And now I need to tell Matlab what are the variables, and variables are x and y. So this way I define the differentiation of f2 of x. I think there is going to be another one, f2 of x, and this way Matlab understands what's the function. By now the g2 function is not an expression. Matlab understands it completely. To show you how does it work, let me pass some numbers. So now I put x value as 1 and y value as 2, and if I hit enter, Matlab has no problem calculating the value of the derivative at that specific point. Let's go with g of negative 1 and 37. Sorry, g2. The name is g2. As you see, we could easily use what we learned before and expanded that into partial derivative thing. And don't forget to create multiple functions and play with them. And this is a very good way to learn Matlab and be confident in each section. With that said, I see you in next video. Hello everyone, welcome to Matlab Programming Class. In almost all engineering activities, we are required to show the result of our work in a form of a plot, a graph, or a figure. The reason is that pictures can entail a lot of information which is valuable. You can show the result of millions of lines of programming inside only one picture. So it is important that we know how to work with plots and figures inside Matlab. I would like to start by a very simple example. So I would like to introduce a vector of x, and I'm going to put random like 1, 2, 3, 4, 5, 6, 7, 8, and 9, just as a sample. And then y, it's going to be, I go with -1, 3, -2, 7, 8, and 9, 3, 6, and let's go with 8. Okay, so let's make sure 1, 2, 3, 4, 5, 6, 7, 8, and 9. I think 1 is more. 1, 2, 3, 4, 5, 6, 7, 8, and 9. No, that's okay. So we had 9 elements up there and on X, and then 9 elements on Y. So I wrote 2 vectors X and Y which has the same length, and now I can plot the graph as X and Y. This is the basic function for plotting X and Y. And when I do that, you see that Matlab just graphs the plot for us. And it's very interesting because right away we can explore the functions up here, and each one of them gives us extra ability to work with the picture. For example, this magnifier we can increase, and then with the -1 decrease the plot. We also able to move the plot, especially for sine, when it's sine and cosine, when it's continuously. When we don't define the range in a limited way, we can go and just explore for bigger values. We're also able to rotate the plot in 3D if you like, and also tracing. It will also enable us to trace the data. So point by point, I'm using my cursor. Let me adjust it. And then you can use this feature, and then with the arrow keys on your keyboard, you can move through the points. You're also able to mark the graph and then put colors, define the color, which color you would like to work, and put legends of data and stuff like that. And we work with all these features. The first thing that I would like to say is that if you look closely, there is no labels on X and Y, and also there is no title for this plot. So let's create them. We can define the label with the label function. First, we say that it's for X, and then label, open parentheses, and close parentheses. In between, we put 2 single quotation. Inside, we put X values. And again, with Y label command, we put Y values. And when I hit enter, if you come back to the graph, you see that now we do have X label and Y label. We can also do the same with title function. We can say our first plot, and then we see that our first plot appears above as the title. In some specific applications, it's much more convenient to have the grids on. So we put grid on function, hit enter, and when we get back to the graph, we see that we now have a very beautifully graphed plot with grids on. You're also able to save and print the graph, and also copy the figure and paste it in someplace else, like a Word or your homework or your technical paper, whatever. You can generate the graphs here and then paste them inside your document. In next video, we explore the graphing and plotting in more detail. Hello everyone. In this part, I'm going to continue graphing and plotting function, and I'm going to show you another way to plot the variables and the graphs. So let me bring back the X. This is the X and this is the Y that we had. Also, you know that in Workspace area, you do have these variables as well. If you come to here on plots and click enter and click it, you see that you're given some options. Please note that your plots may be inactive, and the reason is that you have to click on these values and make them active. Then this area will be accessible for you. For example, you need to plot x. So you can just click on it and you have x, or you can plot y like that. And you see that the x values are normally taken into consideration without telling Matlab explicitly. So I can use different types of graphs as well, like this, or this, histogram, semilog, and log stem. There are plenty of options available, and I encourage you to play with them, explore them. Which one do you like to work with most? And it's fun that we can plot all these graphs so easily. So let me clear the screen. In this part, I would like to tell you about different options for plotting graphs and variables. As we learned, the normal style for plotting was like this, x versus y, in this format. Please note that this is the most basic type, and we can, let me type it so I can get the suggestion. Okay, so plot x and y, we can put the value for x, the value for y, and also a lot of properties, a lot of values which are really, really important. To give you an example, let me type x and y, and then we have another optional section, and we put comma and then 2 single quotation, close parentheses. What comes inside these single quotations can change properties of our graph. We can change the color, we can change the style, and also the marker. To show you an example, I would like to graph the plot in magenta color. So I put M here, and if I hit enter, you see that now the color of the graph is magenta. Let's try another one. I try cyan, very good. Let's go red, like that. And other colors like blue, white, and black. Let's go blue, black. Let's go black because we had blue. Okay, so this is the black color. Also, we can, instead of color, we can define the style. If I put 2 dashes, and now my graph is in dash. If I put colon, I do have in dotted format. And also I can put dash dot. And this is exactly what I receive at the end. When it comes to styles, I can use plus. And now you see that the graph is in plus, small pluses all over the graph. Or I can use O, letter O, and now I have circles. I can use asterisks like that. Other stuff that we can use is dot. We can use caret sign to get like a triangle. We can use S to get a square. And finally, we can go with D, which is a diamond. So these feature the last column, which is optional, give us more access to plot, and we further can customize the plot. At the end, let me type the plot x and y, and this is the normal plotting that we had, and you witness how many customizations we were able to implement on this single graph. In next video, we will explore the graphing in more detail. Hello everyone, welcome back to Matlab Programming Class. I'm Tunchi, and in this video we're going to work with plotting, customization of the plots, and stuff that make the plot more appealing. In previous video, we learned how to plot x versus y and then tweak it using colors, dashes, and styles and stuff like that. But for example, let me bring our x and y. So this was the function that we worked with, and we learned that by tweaking the last item, by just adding one item here in single quotation, which can be color, style, length, line width, and stuff like that, we can change the plot a little bit. How if we want, but we saw that we're only able to do one customization at a time, like black. But the question is, what if I want the color black and I want the dashed line at the same time and I want the marker of the circle at the same time as well? So I learned 3 types to modify this item, but I was only able to use one. In this video, I'm going to show you how you can combine these 3 features. So for the first item, let me put M as magenta color. So this was the magenta. And let me go with style. Let's go with dash dot, like that. And for the last item, let's go with S or O. I think it's better. Okay, like that. Now, I wanted to combine all these 3. I can do it easily by writing it together. So, OM dash and M. And it doesn't matter which one you just type first. You can type M first and then dash dot and then O. It doesn't matter. So if I hit enter and if I look at my graph, I see that the color is magenta, the style is dash dot, and also the markers are circles. We can do we can change the color to black that easily, or we might be interested to do it dash type, or we might like it diamond. So you see that we're able to do multiple customization at the same time. With that said, let me clear the screen. Another interesting thing that we can do is to plot more than one function on a single plot. So let me start by defining the x, a new value. I'm going to put pi divided by 150 and up to 2 pi. I think it's enough. I created an array between 0 to 2 pi with this value as incremental value, and then I can create y1 as sine of 4x. This is my y value, and now I can plot x versus y1. And this is the graph. Now, in order to plot another graph, what I can do is to use a function, to use a command called hold on. So if I do that, and then I define my next function that I would like to have, I call it sine of x. Now, what I can do is plot x and y2. Now you see that I have 2 plots at the same time. So what hold on does is actually when the plot is active and you can see that, hold on, reserves the plot, and then plot the second item into that plot as well. If we don't do that, if we don't use the hold on, it's gonna overwrite the plot. We can also use different color for that. Let's go with red. Now it's more clear. Let me clear the screen. Another way that we can do this, we can get the same result, is through plot function. And then what's the x value? The same thing. And we do have y1. Again, we can add another plot here at the same time. So, comma, what's the next plot? X. And what's the y plot? Y2. Close parentheses. So we do have one x, one y1, another x, and y1, 2. These two are going to be one function, one plot. These two are going to be the second one. If I do that, you see that I get the same result. Matlab automatically labels the second one as green because we didn't specify it. However, I can easily change the customization of each plot. So for the first one, I put 2 single quotation. For the second one, also 2 single quotation. In first one, I would like to go red plus and dashed. In second one, I would like to go sign, colon, diamond. If I hit enter, now you see that I've created 2 distinctive graphs on a single figure. Let me clear the screen to give you another example. Let's go with y1 function as sine of x multiplied by 2. Then y2, 3. Then y3 function. I'm just creating 4 different functions. y4, 5 function. Very good. Now I created 4 different functions. What I can do is plot x, y1, x, y2, x, y3, x, y4. So I can create the plot, and because I didn't define the color and a style, Matlab is going to select it automatically like that. Sure, I can change each item. Y2, let's go single dash, Y3, Y4, let's go S. So if I do that, Matlab just customize the graphs. Hello everyone, welcome back to Matlab Programming. Today we're going to learn a very interesting and useful feature in plotting called subplots. The subplot command will enable us to divide the figure or the plotting figure into a smaller section and then draw separate distinctive functions and plots inside each one of these subdivided grids. So let me show you what is the format of subplot, what the format of subplot will be. I put comment here so you can see what I'm doing. So subplot will have 3 elements, M, N, and P. M refers to as number of rows, N refers to number of columns, and P indicates which area we are interested in, which area we are graphing the plot in, which area we are graphing the plot. For example, if I put subplot 2 to 1, what it means is divide the figure into 2 rows, 2 columns, which means 4 spaces. Imagine this Matlab interface that you see and divide it into 4 sections. Here will be 1, then 2, here 3 and 4. We call it the subplot. And when we say 1, it means that come to the first portion, the upper left portion of the square, and we're plotting in that. For example, I put subplot 2 to 1, and Matlab creates something like this. And I would like to say that plot x and sine of x here. And notice when I hit enter, if I come, you see that Matlab plots the sine in this area. Why? Why not on the second part? Because first of all, we have four sections, and we told Matlab that we're interested in the first element, the first section of the graph. Therefore, Matlab jumps into this part. What if I put 2, 1, 1? If I do that, now Matlab just divides the whole graph into 2 sections, because I told Matlab I have 2 rows, 1 column, and I'm interested in the first element, the upper left. So 2 sections, upper left will be this first item. And if I put plot sine, now sine will be drawn on only this part. How about I want to go subplot 2, 1, 2. Now I'm interested in the second part. Then you see that a new section is dedicated for the second plot, and I can go plot x and cosine of x on the second part. And you see Matlab just draws on the second item. It's noteworthy to mention we are fully able to apply what we learned before here as well. So if I come here, you see that all those customization, all those modifications are available here as well. Let me clear the screen. We also have some specific graphs and plots that we work with them a lot. One of them is bar. So if I put bar y, and you see that we do have the bar graph like this. Let me clear. Another graph that will work a lot is bar 3. Let me bring the x value and also y1, y2, y3, and y4. So I do have x, y1, y2, y3, and y4. One of the famous functions that we work is bar 3. Let's go y1. So what bar 3 does is create a 3D graph of a 3-dimensional graph of the y function in the bar format. Another one is pi. So pi of x will be a pi function, maybe because it was too small. Let me create pi of y2. You see that it's a bar graph. There are special graphs that we worked with them a lot, and we're going to learn some of them here. Let me clear and CLC. Let me create x equals 1 through let's go 5, 3, and 9. And then y, I'm going to create x 1 through 5. So what I did is to put x here, the whole x comes here, and then 1 through 5 will also be added to that part. Let me take the semicolon so you see that what we have created. This is the y function. Now let me create subplot of 2 and 2 and 1. So we have 4 figures and we're interested in the first one. Let's go like that. Let's go bar of x. And for the title, let's go bar graph for vector x. Sorry. A bar graph for vector x. Now, if I activate the graph, you see that we have the title and we also have the bar graph. In the next part, let's go to subplot 2, 2, and 2. So we're interested in the second part. In this part, let's go bar of y. And for the title, let's go with a bar graph for y. That's good. And if I activate it, you see that now we do have a bar graph, and because it has different values, it has 2 rows. So this is the row 1 and this is the row 2, and because we do have different elements, it has different colors automatically. We're also able to change the colors and the stuff that we learned previously. For the subplot 2, 2, 3, let's go bar 3 of y. Bar 3 of y. And for the title, we go, this is a bar graph bar 3 graph for y. And when I create this, you see that now our bar graph is created in a 3-dimensional form. And lastly, for subplot 2, 2, and 4, we can go with pi of x. Title, this is a pi graph for x. And now you see that I've created a bar graph for x too. It is very, very easy and convenient to plot graphs, very sophisticated graphs, inside Matlab very easily. Also, you are able to create different forms for graphs and histograms and stuff like this here, and work with labels. You can type label, x value, and just customize it as you wish. There are a lot of customization options available for you. Hope you enjoyed this part, and I see you in next video. Hello everyone, welcome back to Matlab Programming course. In this video I decided to show you another way to do the plots, which are very important in Matlab Programming. And due to the fact that I got many emails about how to do the plots, and it's sometimes difficult to remember all those combinations. So I decided to show you another trick that you can use to do the plots in an easier way. So for example, start by a simple one. I'm going to create x, let's say half to 2 pi. And then this will be x, and for y, let's go something simple like sine of x. Okay, so I created this. Now I need to plot x and y. So we can create something like this, which is very simple, and the answer would be like this. If you click on this icon, Show Plot Tools and Dock Figure, by clicking on this, a new window will be opened. Let me resize that so you can see the whole. Okay, so this is the plot that you got after clicking on this icon. Now, please note that there are a lot of options available for you. For example, if you need to like show where are the special places on the graph or mark somewhere, you're totally able to do that. And you're also able to mark the X label. So I can say input, and input appears here. You can easily adjust the limits. Let's go to 5. And for the y-axis, you can do the same. For example, sine of x. So you see that you're able to do these modifications very easily. And also, if you click on the graph itself, you're able to choose, let's say, the color, or you're able to choose the type, the length, and also you're able to kind of select the type of the graph. For example, you need a bar, you need area, stairs. So it's really easy to change the graph and just save it as the final work. So in this short video, I just wanted to show you that there are numerous options for you to choose from. So you're free to come here and like select what type of graph you need and just adjust it the way you like. And even you're able to change the color of the background. Some of you had to ask me how to do it. So I hope that this short video would help you to produce the desired outcome you were searching for. Thank you very much, and I see you in next videos. Another common use for a for loop is to combine it with an if statement and determine how many times something's true. For example, now I'm going to write a program that gets a list of numbers from students and then finds out how many scored above 90, and then count them and returns the final result. So let's get started. I will open our test, and here I create scores, a variable that I'm gonna put the numbers inside. So let's go 30, 65, 91, 87, 56, 93, 82, 99, and 90. So this is our score. And then I create a variable called count because we need to count our numbers. And initially we put it 0 to make sure that there is no previously written value inside that variable. In next line, we start our for loop. So for our index will be k1 start from 1 up to how many numbers we do have in this vector. We're going to count it automatically through length function scores. And then we want to tell that we're not interested in all the numbers. We're only interested in those above 90. If scores of k were above 90, then count equals count plus 1. What does it mean? It means that if the scores were above 90, count them. Then we go to end and next end. Because we had an if and we had a for, we needed 2 ends. Next, we're gonna display the result. Display count. We finished writing our program that receives a number, starts counting the numbers and evaluating them, whether they're above 90 or not, and then returns the result. So let's run the program and see what happens. Right now we do have 91, 93, 99, and 90. However, 90 is not above 90. It's equal to. So let's run it. When I run that, the result is 3. And that was what we expected because 90 is not counted. So let's go here and change this to equal sign. If I do that, this time the result is going to be 4. Another thing that we can test here is that maybe you think that why we need a score of k. Let's go with the scores because the scores are recorded here. If the scores were above 90, let's see what happens. As you see, the value is 0. So what's the problem? It's very important to note that this k is the same k as index. So what it does, it makes sure that we're going to search through every single number inside our scores and not just the whole score as a vector. If you don't do that, Matlab takes the score as a vector and doesn't investigate each single part of it. By putting k, we make sure that Matlab understands each single individual scores and count them one by one. So by now, it's 4. Let me bring this to 81. And if I hit enter, you see that the result is counted to 3. It's a very good and easy example that we can use to firmly understand the purpose and the syntax of Matlab executing for and if statements together. Hello and welcome back to Matlab Programming Class. I'm Hossein Tutunchi, and in this video I'm going to show you how to perform the selectional operations, the if conditions. So let me clear the screen. Most of the time the find function performs very well and it can do what we're searching for. However, there are occasions where we need to test some criterion and then decide based on the result. To give you an example, let me start the test and let me clear that. The way that we define the if condition is if we do a comparison or test a relationship, and if it was true, we do some statements and perform them accordingly. And at the end, we run end, which means that now the if loop is complete. So let me show you how it works. X equals 3. I define a value for x. And then I'm going to write a condition, a loop for that. I would like to say if x less than 4, this was the condition that we talked about, the comparison. And the second part, which is statement, if x was less than that, this is a function which displays a number or a statement. Whatever we put inside the single quotation in this function, it will be shown later. So the x value is smaller than 4. And then we would like to have the value of x shown, and at the end we put end. Notice that Matlab automatically arranges the outline and program, which makes things more neat and clear. So with this one, let me save that. And then we call it test. The x value is smaller than 4, is 3. Why it ran? Because the condition was true. X was 3 and X was indeed less than 4, so the this function and the inside portion of the if condition ran. However, if I put X to 5, now X is not less than 4, and let me save it, and then I call it here, test. You see that no result will be shown, and the reason being is that the condition was not true. In Matlab programming, and if condition, if the condition part, if the first part is not true, then everything else will not be operated, and the end function will just end the loop. Now we're going to explore another function called if-else. If-else is when we have more than one condition. It's not like that always everything is bigger or smaller than something else. Maybe there are multiple conditions. Maybe we're interested into ranges. If X was between 10 and 20, then do something. If it was between 25 to 35, then do something else. And because we need these multiple if statement and if condition, we've created the if-else structure, and we also have a nested format of that I will explain in a minute. To give you an example, if X was bigger than 0, then go and calculate the log of X. Else, what it does, else means that if X was not bigger than 0, what happened then? Then disp to single quotation, and between we put the input of log cannot be negative. And end. So please note that in else if function, we can have only one criteria more than the normal if function. So if we had two criteria, two possibilities, we can use else if. And in nested format, we can have more than that too. So let's go with this one. If X was bigger than 0, then calculate the log of X. But if X was not bigger than 0, then tell us that it cannot be negative. So if I put X equals to 5, which is a bigger number than 0, then I call test. You see that the value is calculated because indeed 5 was bigger than 0. How about if I put X equals to negative 6, which is smaller than 0? And then I call test, and you see that the input of log cannot be negative. So it tells us, it alarms us that it cannot be negative, and it's very good. Also, let me show you something interesting. We can do, have you ever seen that when you do something by mistake, the computer beeps you and just, it's a speaker sound called beep. And actually there is a function in Matlab called beep that we can do that to draw the attention. Here, we're gonna modify our function. If X was bigger than 0, then simply go and calculate the log of X. If it was not bigger than 0, then first do a beep, beep, and then display the result. Before I run this, let me increase the volume of my speaker, and then when I click, look what happens. Now the value of X is negative, which is less than 0. So I call test. You see that there is a beep. Test. And it is very nice. We can use the beep function to draw attention. Hello everyone, welcome back to Matlab Programming Class. Today we're going to learn about else if. Else if is very important because it has a wider range of capabilities than else or if alone. What it does, it gives us the ability to classify the range that we're going to test into multiple sections and test them one by one. So let me show you how does it work. Imagine that we're going to register some applicants and then give them driver license. The driving license in the United States is going to be issued based on the age. For example, a person who is less than 16 years old cannot apply for a driver license. And also, a person over 70 years of age needs a special type of license. We have registered a couple of people, and we're going to write a program that can classify these people into different groups and tell them what's going to be the next step in their application. So let me type it like that. If age is less than 16, tell them this sorry, you are too young to apply. This was the first one. And instead of else, because when we go else, it means that the next step will be end. But we have other subsections as well. So we go with else if. Else if age was less than 18. So if it was less than 16, we cannot do anything about it. But if it was less than 18, then what happens? We can go this. You can apply for youth license, which is a special license as well. What else? Else if, now we're going to define a new criteria. Else if age less than 70, then tell them you may have a standard driving license. Yay! And this is going to be the last criterion. The normal, we have if and then else and then and. But between we had two else if, and the last item again normally will be else because there is no other classification as this. Else, and pay close attention that I didn't specify an age criterion for the else. And the reason being is that it's clear. Less than 16, we defined it. Less than 18, we defined it. Less than 70, we defined it. So the last item will be over 70. We don't need to specify that last item. Else, this drivers over 70 require a special license. Like that. And at the end, we'll put an and. We wrote the program, and if you see the green bar here, it means that there is no warning, everything is okay. The only thing we have not defined is the age variable. So if I go age equals 15. So let me call test. We have not saved it yet, so we save it. And then we go test. What happens is that because 15 is less than 16, sorry, you're too young to apply. Oh, I see that I do have a misspelling here as well. So let me go and change this one, save, and then let me CLC and do it again. So age, we have 15, and then let's go test. Sorry, you're too young to apply. Sorry. The next item is, let me clear the screen. We put age 17 and call test. You can apply for a youth license because it's more than 16 but less than 18. The next item, if we define age as 19, then what happens? 19 is more than 18. So let's call test. You may have a standard driving license. Yay. How about age 65? 65. Then test. You may have a standard driving license, we get the same result because we put the criteria on 70. So let's clear the screen. Age is 71. And then test. Drivers over 70 require a special license. You might be thinking, what if we put 70 here? And we call test. And you see that drivers over 70 require a special license because we didn't define that less than 70, we defined above that, which means because we defined that less than 70, not less than equal than 70, can have the standard driving license. So they're categorized as over 70. So far, we've learned a lot in Matlab programming, and these are the most important operations and functions in Matlab programming. There are tons of other applications, functions, and formulas in there, but they're only the combination of all we've learned so far. It is really necessary that you instill all the knowledge you learned during this course through multiple examples, because that's the way that you can be a proficient Matlab programmer. With that said, I'll see you next video. Thank you. Hello everyone, welcome back to Matlab Programming Class. Today we're going to continue our journey in Matlab programming with another important concept, which is not only important in Matlab programming, but also in any other sort of programming language. It's so fundamental and useful that you will find that either directly or indirectly in other languages as well. And the topic is using loops. The structure of the for loop is very simple. The first line, let me bring up our sample files. This is the one that we used already. So the structure of the for loop is very simple. The first line identifies the loop and defines the index. So I can put it like that. For index equals, and this side, most of the time we do have a matrix. And then I will explain what are these in a minute. And then comes commands to be executed, and the last end. This is the structure of a very simple for loop. What it does is, in the first line, we do have an index. And what is index is a variable that we use to count the number of the ways or the number of times we perform the commands in the second line. Therefore, depending on the number here, the index, we may have different numbers, code execution, or even the results. The last line, end, will terminate the for loop and defines that the process is finished. Most of the time, the index will be in a matrix format. For example, we come for I equals 1, 2, and 3. Then we go to next line, and as I hit enter, you see that a box will be created automatically. I, which will be the command, and the end. As soon as I type end, Matlab automatically just sorts them to make it more easier to see. And I'm also able to click on this sign to minimize or expand it. Let's go over our example. In the first line, we do have for I equals 1, 2, 3, which is going to be our index, the matrix, and the command, the second line, will be only I. So what happens, it's very important to note that whenever the condition is true or the index is passed to a for loop, they're going to be executed one by one. For instance, for the first item I equals 1, 2, 3, the first item will be 1. So as soon as Matlab understands that the first item is 1, the value for I will be set to 1. In the command section, we only have I. So what was the value of I in the first line? It was 1. So Matlab puts 1 instead of I and then goes to the next line, which is end. The loop terminates for the first item in the index. Now Matlab automatically jumps again into 4 to execute the second item, which is 2. Then pass it to the second line, which is command, and the value will be 2, and then to the third to terminate the second item in the loop. We only have one item left, 3. So Matlab jumps again to 4 and starts putting 3 instead of I. Once that loop is also complete, there is no item left in index matrix, so the loop is finished. Let me save that, and now I can call it test. And as you see, Matlab runs it one time I, the second time I equals 2, and the third time I equals 3. It's very important to note that each time Matlab executes it, it will also show the result. However, if you right now call the I, you will see that the value for I is now only the last item. We could achieve the same result by bringing I outside of end loop. And if we do that, you see that let me clear the screen. And if I do that, test, you will see that Matlab only shows the last value. And that's okay, because we may or may not have the command. They're optional. But the last item after end will only show the last result and the last execution. Please allow me to give you another example. So we put clear and CLC. Always put these in the beginning of your programs. That makes life much easier. So another example will be 4 as the index, k equals 1 through 4. This is another way to show the index. It can come within a vector form or a matrix form, and also in this format. As you know, it is already a vector. So for the next line, let's go a equals 6 and to power k and end. That's a very simple example. So what we expect is that when k equals to 1, the value will be 1, a equals 6 to power 1, and the result is 6. Next time, k equals 2, so it comes a equals 6 to power 2. The third time is going to be k equals 3, and the process will be followed the same as well. Let me save and call it test. If I do that, you see Matlab the first time brings 6, 36 to 16, and the last time is this. How about the value of k at the moment? It's only 4. The last item that we executed is going to be 4. In next video, we review a combination of for and if together. Hello everyone, welcome back to Matlab Programming Class. Today we're going to start a new chapter which is very important in our class, and it's going to be about the logical loops and conditional situations in Matlab. Let me define the value for x equals to 4, and the y value, let's go with -2. So I put two values for x and y, and I can test the relationship like that, x less than y. Let's see what happens. The answer is 0, which is a negative. It means that x is not less than y. Y is smaller than x. So if I calculate again and reverse the order to bigger, is x bigger than y? And if I hit enter, the answer is 1. 1 means positive, 0 is negative. In another example, we can test it like x to 5, which is this, and then y equals x plus 3, which is going to be this. we do have a vector of x and a vector of y. And now we can test, is x smaller than y? All of them are correct. Means 4 is bigger than 1, 5 is bigger than 2, and vice versa. How about if I change the sign? All of them are incorrect. Let me clear the screen. Let me put it like that. -1, 2, 0, 4, and 6 will be x, and y will be 2, 1, -1, 5, and 9. This is going to be the value for y. And you notice that their numbers are the same. They do have the same number of variables. So let's go with x bigger than y. Is x bigger than y? Some of them are 0, some of them are positive, or 1, because the second element here is big. The second element in x is bigger than the second element in y. But the first element is less than that. And if I reverse it, the result will be reversed. We can also put less than or equal. The way that we'll put less than or equal is this. Can we put it here? You see that Matlab always demands that the equal sign should be on the right side of any operation. Therefore, this will be correct. And also, this will be correct. Because this equal sign is on the right side. How about x equal y? Before running this, I would like to explain that in any programming language, when you put x equals 1 only with one sign, it means that put the value of x equal to y. It is not a request. It's not a question. It is a command that when you put 1x, it just makes their values the same. However, when you put two values, two equation signs, or two other equations together, when you put two operations together like that, Matlab is going to test it. Is x equal to y? And the result is negative because they're not equal. None of their elements are equal to each other. Similarly, we do have this sign. And if I put x, y, it means that is x not equal to y? Is x not equal to y? And if I hit enter, the result is correct because the values in x vector are not equal to y. So let me put x here once more. Before that, let me clear the screen. So let me put x again. And now I put y, but instead of that, I put 0. So make one element the same. And if I do the operations again, you will see that the third one is not correct. Means that the third one are equal, but all of the other elements are not the same. In continuation to previous video, we're about to test the logical operators. So what are the logical operators? The first one is ampersand, which is and. The second one is not. Third one is going to be or. It is shift and the button on top of enter key. And the last part is XOR, which is known as exclusive OR. And we're going to learn to work with them today. So let me clear the screen. I have created a M file here. Let me delete that and we create one together. So click on new script and a new script will be created for us. Now we can put save, and I type test, save it in Matlab folder, and now the test is created here. Here I would like to put the value for x to 1, 2, 3, 4, and 5. And also the same for y value, -2, 0, 2, 4, and 6. So I created two vectors for x and y. Now I would like to test, is x less than y? If I hit enter, you see that the answer is 0, 0, 0, and 1. It means that the last item on the list, which was this one, is actually y is bigger than the x. Note that I can call the script here as well. I put say test, and it will run. So next, let me create another values. Let's go x 1, 2, 3, 4, and 5. And let's go for y, -2, 0, 2, 4, and 6. Let's create another one called z, and we go 8, 8, 8. Let's make it all 8. Now, I would like to test if z is bigger than x and z bigger than y. Now I do have two conditions at the same time. Is z bigger than x and also z bigger than y? So let's test that. Save it, and we put test. Let me put x the z value. I have to run it first. So what is the x, what is the y, and what is the z? Now I call test, which performs the operation that is all the values in z bigger than all the values in x and also all the values in y. It's a test, and it turns out to be positive. It means that each and every single element in z are bigger than their corresponding elements in x and y. How about or, like that? If I run that, you see that the answer still is going to be positive. So let's change the order. If x bigger than y, and or x bigger than z. So it checks the validity of this operation to see if all the values in x are bigger than y, or all the values in x bigger than z. And the answer will be correct for the first third elements and incorrect for the last two ones. Let me clear the screen. Another important function is find. Imagine that we have a speed vector, and we have recorded a speed of cars in a highway with 63, the first one, 67, 65, 72, and 69. Let's go 78 and 95. One of them were really fast. Okay, so these are the speeds of the car in a highway. We have 1, 2, 3, 4, 5, 6, 7 cars. We have recorded a speed, and we want to give them ticket. We ask find a speed which are bigger than 65, bigger or equal than 65. We're gonna give them ticket. We're gonna find them first to see how many fits the criteria. But when we run the function, we see that it's not 0 or 1, but it's some numbers. And if you pay attention, these are the indexes. These are the index numbers of the elements inside the speed function. So the first one, 67, is the element which is bigger than equal to 65. The third one is also equal, the fourth one, the fifth one, and there is no 1 here because the first one was 63, which was less than our criteria. If you want to find the actual numbers, what we can do is to give this one a name. So we call it result, like that. And then we can go speed of result. And if you do that, you see now the actual speed values appear. You can play with these results and just try them, make different combinations to see which one works. Hello everyone, welcome back to Matlab Programming Class. Today we're going to learn another type of loops which are widely used in programming, and they're called while loops. While loops are very similar to for loops, but the big difference is that the way Matlab decides whether to repeat the loop or not. While loops continue until some criterion is met. Let me open the test file, and because we need this, let me make it comment, and then we get back to that later. So the format for while loops will be like this. While a criterion was okay, then commands will run, and we do have end. So here's an example. Let's have k value equals 0, and then while k less than 3, k equals k plus 1, and end. So what we do is that we evaluate the value for k, and if it was less than 3, we add 1 to it and continue again until the while criterion, this criterion was no longer true. So let's run that. When I do that, you see, because Matlab value for k, because the initial value for k was 0, it ran 3 times. But when k became 3, right now if I type k, you see that the value is 3. So the criterion was no longer okay, and Matlab stopped the loop. We could use k as an index number to define the matrix, or just as a counter. Similar to if loops, while loops can also be used to count how many times a condition is true by simply incorporating an if statement. And recall that the test scores that we did in previous example, let me bring that. We're going to do that with while loops here. So we do have the scores, and we put count to 0. And here, instead of for loops, let me write it again, all over again. Now we do have while, this is the criteria, while k, and we should add a k here too, so k value is going to be 0. So while k less than length of scores, this is our new criterion, and then what should we do? Add 1 to that value, and then if scores of k was bigger than 90, count equals count plus 1. Here is similar like the previous example. And then we do have one end for if and one end for while. At the end, display the count. We have now rewritten our program using while. At the first line, while k is less than the length of the scores, 1 will be added to the value of that. Please note that here, the variable count is used to count how many values are greater than 90. However, the variable k is used to count how many times the loop is executed. So let's run the program. When I do that, we got the same result because now we do have 1, 2, and 3 values above that. Let's go with 92, and if I run the program, now we do have the same result. As you see, For and while loops are very, very useful and can be combined with if statement to do a wider range of applications. Thank you very much and see you in next video. Hello everyone, welcome back to Matlab Programming course. I'm Hossein Tutunchi, and first of all, let me take the opportunity to thank you all for showing such a great dedication and commitment toward this course so far. I hope you've made great progress in Matlab programming. In reality, we've learned a lot during past weeks, and by now we're familiar by the most important Matlab functions that are used in any programming technique out there. I have designed a special chapter for this course to use what we learned so far in a context and solve problems and projects. It would be great if we can see them in practice and test their usefulness. With that said, let me start a new topic here. Often in Matlab programming, we're required to do a repetitious job. For example, imagine someone asks you to write a program or script that calculates the area of a circle. Of course, the only thing that we need is the value of the radius, and this is going to be a very, very simple example. However, imagine someone asks you to write a program that calculates the area of 1,000 circles with different radiuses. Although it's not difficult to do with a loop or other techniques, we're going to learn a tool which is really helpful in these circumstances. Instead of opening the script each time and changing the value of the radius, and then run the script, it would be great if we could write a program and then call it over and over again, pass an argument to that function and get the result. And that's exactly what we're going to do. Today we're going to learn functions. Functions are small programs or routines that can be called over and over again to do a predefined job or algorithm for us. In order to create functions, there are multiple ways. One way is to come here on new and click on the new icon. You can go and create a script, or you can go and directly create a function. Let me show you what's the difference. If you open the function, the format of the function is already written for you with some notes that you can read and understand by yourself. However, let me create one from scratch. Don't save. And we come here, open script. In this example, I'm going to show you how we can write a program that calculates an average of two vectors or data set. Imagine we have an x vector equals 12, 5, 34, 87, 35, 90, 124. This is our data set or information. There are 7 elements inside that. Next, I'm going to introduce another vector called capital N. And what is capital N? Is the number representing how many times each element inside the X is repeated. For example, 12 is repeated 2 times, 5 is repeated 4 times, 34 repeated 56 times, 87 12 times, 35 6 times, 90 9 times, and 124 also 14 times. The problem is that we have a vector x and we have a vector n, which indicates the number of the times each element in x is repeated. We want to calculate the average. Normally what we do is we multiply each element in n onto x and then sum the elements, divide everything on n to get the average. Here we're going to learn to create a function for that and also create a smarter program. Let me make some comments for these two. Input will be these two functions. And now we're going to create a function. The first thing you need to do is type function space. As soon as you type function, Matlab recognizes that by making a blue. Next, we need to make a name for this. We're going to calculate the average, so AVE is going to be a proper name for that. Then we call it equals. We're going to create a function called AVE that what it does, it calculates the average of a data. So next I call it my average. This is the name and it's arbitrary. You can put anything for that. The next element is going to be open parentheses, close parentheses, and in this area you need to tell the function how many arguments it needs. Remember the area of the circle, we only needed one variable. Therefore, if you want to create a function that calculates the area of circle, there was only one argument needed for my average. However, here we need two, because in order to calculate the average, you need the summation of a data set and then the number of the data set, so you can divide them together. So the first one is going to be x, comma, next one capital N. These are exactly the ones that we have calculated here. Therefore, the function receives a data set and the number of the data set, and then hit enter. In this part, we're going to create the function body and actually the program that solves the problem for us. The first thing we need to know is how many elements are in our data point. So let's create that. We learned in vector and matrices that in order to find the size, we can use size of, let's call size of x as a variable, and we pass x to that. So size of x will calculate the size of the vector, put the value inside the size x variable. You will also notice that a handle is created connecting the function to the rest of the program. We need to repeat the same thing for the second input as capital N. So size of capital N also equals size of n. In these two lines, we will gain the number of the elements inside x and the number of elements inside n. One thing that you should notice is that vectors, when you pass size function to them, returns two elements. Let me show you. If I bring it here, this x, and pass size x, what it returns is not a single number, but two. And also you will notice that we always have the first element as 1 because it is a vector and the number of the rows is going to be 1. However, what is important for us is the second element, 7. We actually learned that we can extract the second element like that, size x of 2. If I pass this one, I'm able to extract only the second element of the vector x, which is the one important for me. Let's get back to our script file. Here, I can calculate the size, the second element, and actually get the number. What happens then is that I'm able to calculate the average easily. However, before proceeding to that section, let's make our program smarter. What happens if the number of the elements inside these two vectors were not the same? How about we had 9 elements inside x and 4 elements inside n? Therefore, there's a problem in our statement and we need to correct that. We need to inform the user that there is a problem with your script. How we can do that? One thing is that when the number of the x elements inside x is not equal to the number of the elements inside n, we can write it by an if. So we can write if size x of 2 was bigger than size n of 2, or we call it pipe, or another scenario would be size of x2 is a smaller size n of 2, right? Because in these two scenarios, the number of the elements inside n is not equal to the number of elements inside x. Also, we could write it even easier. If size of x2 was not equal to size n of 2. We learned that this tilde sign before equal sign make it negative. Therefore, instead of writing this line, we can write it even simpler. If size x2 was not equal to size n2, then what happens? Then this span error. This span error. In this error, we can call error the number of elements inside input data should be the same. And also, we can even include a beep before that to get the attention of the user. Hit enter. But what happens if they were equal and we had no problem? Therefore, we can call else. Now we're able to proceed to our program and write the body of the algorithm that actually solves it. So, next element we need is the number of the element inside n, and we call it total equals sum of n. I know that how many elements I do have. Next is to calculate the average. How? I know that 12 is repeated 2 times, 4 repeated 5 times, 34 repeated 56 times. So we proceed to calculate the total value, and we call it S equals X dot multiplication N. Why? Because we need element by element multiplication. We have their multiplication as well, and we can call AVE, which is this one. AVE equals sum of S. This S is going to create a vector with multiplication of all elements. Next, we sum all the elements inside that vector. And finally, we divide it by total. And what was the total? The number of the element we have, the number of the data points we have. We have written our program. However, we do have an if, and we need one end for it. And also, we do have a function. For functions, we also include end. Each function should have a start and an end. And you see that Matlab recognizes the handle and defines the end of the program. So let's run it. First thing we need to do is to save our program. I call it my average. Let's save it. Now we have successfully created and stored our function into Matlab directory. Let's test our work. The first data input was X. Let me bring it here. So the first one was X, and the second one was N. These are exactly the ones I had introduced in our program. Let me hit enter. Imagine these two vectors are given to us and we have written our program. Now we're going to test it. Instead of writing the script over and over again or changing it, we can type my average. And as we introduce here, we told 2 arguments are required. What are those? The first one was small x, the second one capital N. If I hit enter, the value is created. Let's change our problem. For example, someone tells you this was 34. Can you calculate that? Of course. My average is going to be different. How about the number inside N was not equal the number inside X? That was one source of problem, and we had anticipated that. We included the if condition, this part, to take care of that problem as well. So let's test our result. Now our N and X have different sizes. If I pass my average X and N, you see that we heard a beep first, and then an error comes up, the number of the elements inside input data should be the same. As you see, we could create a very efficient function that can take care of many repetitious problems for us, repetitious scenarios for us. You can extend this functionality and technique to a lot of programming problems. Hope you enjoyed this video and don't forget to practice. Thank you very much. I see you in next one. Hello everyone, welcome back to Matlab Programming course. There are occasions that we need to find the value of a function for different values of parameters. For example, you have a sign and you wanted to know the value when you pass multiple inputs to that. In this small project, we're going to develop an algorithm that can return the value of a polynomial based on different values that we introduce as input. Since we learned how to work with functions, I'm going to use that. As we learned, we open script and we begin by function. For the output name, I select output equals polynomial because I need to find the value for polynomial. What is the variables or parameters that I use? There is only one, and it's going to be x. In next line, I would create the output. So the output equals, let's create a random polynomial, x cubed minus x squared plus x minus 123. I just randomly created a polynomial. Please note that if you want to find the value of such a big polynomial, it's going to be very hard or time consuming. Therefore, this is one of the benefits of knowing Matlab, that you can write a small script that can solve that for you. In next line, we end up our function. That's it. We created a small script, a small function that not only is able to calculate the value for x, but also you can pass any input to that for the desired results. Let's save our work. I choose the word poly and save it. That's it. Let's test our work. If I type poly 1, Matlab returns it. How about poly 234? As you see, calculating this by hand or even calculator is very time consuming and prone to mistakes. But with one line code, we could just do it easily using functions. We've accomplished our task, but let's make it more efficient. I can now put dot in front of x to make the functionality for vectors and matrices as well. If you remember, when we put dot before an operation, that expands that function for matrices and vectors. So let's save it. Now I can type poly 1, 2, and Matlab calculates both values at the same time. I can even go further. Poly 1, 2, 3, and 4. And as you see, Matlab has no problem calculating all these data simultaneously. Thank you very much and see you in next video. Hello everyone, welcome back to Matlab Programming course. So far, all of the programs and algorithms that we developed were written in such a way that you are both the user and the programmer. But the majority of the codes out there are written for third party or other people to use. Therefore, it's necessary for the programmer to be able to communicate with other people who are using the code. There are multiple functions in Matlab which are designed for this purpose. And today we're going to learn a couple of them. One of the most important ones is input function. And this is how we use it. For example, I call A equals input, open parentheses, single quotation, again, single quotation, close parentheses. In this single quotation, I can ask the user to do something for us. For example, I can ask enter the value for A. And look what happens when I hit enter. Matlab reflects back a question and the user is now able to put a value, for example 1 here. As soon as I hit enter, the value for A will be changed to 1 and I'm able to continue the rest of the code or use the value for A in new calculations. Let me repeat the input function again, and now instead of a number I put a matrix. As soon as I hit enter, the new value for A is going to be a matrix. We're also able to use this to ask for other types of data. For example, what is your name? And I change the A value to name. When I hit enter, Matlab asks what's your name. So let's put my name here, Hossein Tutunchi. And when I hit enter, Matlab reflects back an error. The reason is input is dedicated for numbers. We cannot use it for strings. However, what I can do is, let me clear the screen. What I can do is after single quotation, I can use comma, again, single quotation, S, single quotation. What it does, it tells Matlab that now strings are also acceptable. So we can use strings instead of that number. Let's try that. What's your name? Hossein Tutunchi. Now the value for name is a string, not a number. Another useful function that we use a lot is num2str, and we write it this way, num2str. So what it does, it changes the type of a number to a string. Let me show you how does it work. X equals 1, 2, 3, and this is a vector, right? Y equals, again, 1, 2, 3, and when I hit enter, you see that Y is also a vector. I am fully able to add these two together. However, if I use X equals num2str of X, what it does, it returns the X as before, but if I type X plus Y now, you see that we're not able to do that. This X is no longer a vector, it is now a string. Let me clear the screen. In this part, I'm going to write a program to calculate the area of a triangle. However, we want to ask the user to enter the values for the base and height of the triangle in middle of the program. So let's see how we can do that. Open the script. Here, I type in this script, I am developing a program to ask the user to enter the values for base and height of the triangle to calculate the area. First, b equals base. B equals, I ask the user to enter the value for the base. Next, H is input h is height. So h equals input, enter the value for height, close parentheses, and semicolon, not to reflect back the values for b and h. And then in this part, the area half multiplied by h multiplied by b. At the end, we're going to use this to show the value that we're searching for. The value for area is, and now we're going to use the num to str because we could find the value for triangle area here. Now I can change that to num to str value, open parentheses and close parentheses. What it does, it reflects back this string and then continues that with num to str, which is also a string resulting from this value. Then we close the parentheses, and because we had two values to show, we put it in brackets like that. Let's test it. First of all, we save it, give it a name like, we can put triangle area script, and then we save it. Then we can run it here or call the name there. Let's go this way. I run it. Now the MATLAB asks, enter the value for the base. Hit enter. Now enter the value for height. It's going to be 8. And then enter. And you see that the value for the area is 20. We could successfully develop a script that a third person also can communicate with and enter the value and get the result. Many of the sophisticated programs and games and apps that ask questions during the operation use the same principle. Thank you very much, and I see you next video.